అన్నపూర్ణ
మేడం
లైన్ లోనే ఉండు.
ఉంటుంది మేడం. అది పని చేయవా?
రెడీ చేయవా?
హలో అన్నపూర్ణ,
మేడం
ఆ వీడియో అవన్నీ చేసేసిన చూడు. జస్ట్ మా గ్రూప్ లో వీడియో షేర్ చేసిన
గ్రూప్ లో.
హలో
మేడం మేడం
లైవ్ స్ట్రీమింగ్ అవుతుంది ఇది, ఓకేనా?
ఓకే
దిస్ ఇస్ లైవ్ స్ట్రీమింగ్.
ఓకే ఓకే.
హలో
మేడం లైవ్ ఆన్ యూట్యూబ్ అని వచ్చింది మేడం. హలో
హలో అన్నపూర్ణ
మేడం.
ఇగో ఇది మీటింగ్ లైవ్ స్ట్రీమింగ్ ఎవ్రీథింగ్ అయిపోయింది. పోస్ట్ ఇస్తా, ఇంకా మీ జాగ్రత్త చూసుకుంటారా అమ్మా?
ఓకే మేడం.
హౌ మెనీ ఆఫ్ యు ఆర్ దేర్?
Me and Rubina will join madam now.
Jubina didn't join till now?
No madam, not yet joined.
You asked them, no? I should give the host, no అమ్మా. నేను ఇంకా కొంచెం రెడీ కావాల్సింది ఇవన్నీ ఉన్నాయి, కొంచెం చూడండి అమ్మా. ఫాస్ట్ గా రెడీ ఎట్లనే చేయండి తొందరగా, ఓకే? You are joining with what ID?
అన్నపూర్ణ రెడ్డి. ఇది స్మచ్చ @ దాంతోటే జాయిన్ అయ్యాను మేడం.
You are the co-host. You please you admit, okay?
Okay.
You admit and see to it that you are giving co-host to other people also.
అది
ఇప్పుడు ఇమీడియట్ గా ఒక పని చేయి, అందరికి కాల్ చేసి అందరిని రమ్మని చెప్పు. రమ్మని చెప్తే నేను కోర్స్ ఇచ్చేసేసి నేను కొంచెం వేరే పని చూసుకుంటాను. అట్లా
ఓకే.
కొంచెం అందరికి జాయిన్ కమ్మని ఫాస్ట్ గా.
ఓకే మేడం, ఒక 2 minutes లో అందరినీ జాయిన్ అయిపోమని చెప్పి.
తొందరగా జాయిన్ అయితే నేను నాది చేసుకుంటా.
ఓకే మేడం, ఓకే.
లేదు మ్యామ్ మ్యూట్.
హలో మేడం.
హలో మేడం,
అది ప్రిన్సిపల్ మేడం కో హోస్ట్ ఇస్తా అన్నారు.
ఓకే మ్యామ్.
హలో
హలో
హలో మ్యామ్.
హలో
మేడం, వినోద, సంధ్య మేడం, మానస జాయిన్ అయ్యారు మేడం.
సరే, వాళ్ళ కో హోస్ట్ ఇస్తున్నా. వినోద జాయిన్ అయిందా?
ఎస్ మ్యామ్, ఐ జాయిన్డ్ మ్యామ్ జస్ట్ నౌ.
మానస.
ఎస్ మ్యామ్.
అందరికి డెడికేటెడ్ గా ఉన్నాయా ఫోన్స్ అన్ని?
ఉన్నాయి మ్యామ్.
ఎస్ మ్యామ్.
అన్నపూర్ణ, నువ్వు కూడా అన్నపూర్ణ అని పెట్టుకోమ్మా.
మేడం నేను
WREIS కో-హోస్ట్ ఉంది. నాకు ఈజీగా ఉంటుంది చూడు.
మేడం నేను నా ఫోన్ నుండి కూడా జాయిన్ అవుతాను. అన్నపూర్ణ అని వస్తుంది మేడం దానికి.
రుబీనా జాయిన్ కాలేదు?
రుబీనా అది వస్తుంది మేడం, జాయిన్ అవ్వమని చెప్పాను.
మరి ఆమెదే కదా మెయిన్. మరి రెడీ అయినారా వాటికి కూడా, లేకపోతే అది కూడా లేదా? చూడండి ఒకసారి.
చేసాం మేడం, చేసాం. థ్యాంక్స్ గివింగ్ అవన్నీ
you will handle it properly, no? All that?
Yes madam.
You will handle everything properly, no?
Yes madam.
I mean that giving bouquets avanni okay na?
Okay madam.
Sure kada?
Sure madam.
Okay, so I have given co-host to so many people. వినోదాకి ఇచ్చాను. ఒక రుబీనా కూడా ఇచ్చేస్తే పని అయిపోతుంది. రుబీనా ఇమ్మీడియట్ గా జాయిన్ కమ్మని చెప్పి, జాయిన్ అయినాక నాకు కాల్ చేయి. ఓకేనా? Hello? Did Rubina join?
Yes madam, she is joining. 1 minute. I told her just now she is joining madam.
She should practice a little bit more before the program starts. Meeta వాళ్ళు Vinoda and all, just post
yes,
this YouTube link to everybody so that they'll be sharing. వేరే గ్రూప్స్ కి దానికి కూడా పోస్ట్ చేయండి.
Okay,
and who is going to talk the first in introductory speech? Introduction ఎవరు చేస్తారు? స్టార్టింగ్ వెల్కమ్ చేయాలి కదా, ఎవరు చేస్తారు?
అన్నపూర్ణ మేడం మ్యామ్.
రైట్, అన్నపూర్ణ మేడం చేస్తారు. నెక్స్ట్ అన్నపూర్ణ తర్వాత నాకు ఇస్తావు, అంతేనమ్మా?
ఎస్ మ్యామ్.
సో ఐ విల్ స్పీక్ దెన్
సంధ్య మేడం
will speak, అంతేనా?
సంధ్య మేడం ఇంట్రొడక్షన్ ఇస్తారు మ్యామ్ అశోక్ సార్ ది.
అదే ఫస్ట్ నాది అయిపోయినాక ఆఫ్టర్
ఎస్ మ్యామ్.
మీ తర్వాత
ఇంట్రొడ్యూస్ అశోక్ సార్. ఓకేనా? ఓకేనా? దట్ వన్, దిస్ ఇస్ ఆల్ క్లారిటీ కదా? Did you prepare bouquets for everybody? For me, for everybody? For me, Ashok sir and everybody?
No madam, only for Ashok sir and
Speakers Balakrishna sir. Only for the chief guest.
As we did it previously, we did like this time also we did like that only madam. Rubina join madam.
If possible, fatafat, can you do it? Rubina? Did Rubina join?
Yes, ma'am. She joined.
I made her co-host also. Rubina,
Yeah, yes,
respond.
ma'am.
Hello? तेरा फोन लो दे ना. What happened, Rubina? Did you join? Rubina, did you join?
Good morning, ma'am. Yes, ma'am, I joined.
Okay. The bouquets and all, can you do it fast now?
Yes, ma'am.
Can you do it fast?
Yes, ma'am.
Speak to Annapurna over phone. What to do?
Ma'am, for chief guest, it is ready.
Acha, speak on phone. Speak over phone to Rubina. What she can do. Vinoda and Sandhya.
Yes, ma'am.
Vinoda, Sandhya,
Yes, ma'am.
you both be seeing the admission and everything. Okay na?
Okay, ma'am.
ఎవరు బయట ఉన్నారు ఎవరు? వినోదనా? టేక్ కేర్ అమ్మా వినోద. ఓకే, కార్ సౌండ్ అవి ఇవి వస్తున్నాయి చూడు. Sit in a proper place wherever possible where you can concentrate. Okay na? You people, both of you, Vinoda and Sandhya, take care of the admitting, muting, అందరిని మ్యూట్ చేయండి సరేనా అమ్మా?
Okay, ma'am. Sure, ma'am.
మ్యూటింగ్ అవన్నీ చూసుకోండి. మీరు ఏమైనా ఉంటే అందరికి మ్యూట్ చేసేసేయండి. ఎవరెవరైతే జాయిన్ అవుతున్నారో
Okay, ma'am.
యూ క్యాన్ మ్యూట్ ఫ్రమ్ యువర్ సైడ్. ఓకేనా? అండ్ వెన్ ఎవర్
Okay,
దే వాంట్
ma'am.
టు స్పీక్ దే విల్ రేజ్ హ్యాండ్ ఆర్ సంథింగ్ లైక్ దట్, దెన్ యూ అన్మ్యూట్ దెమ్.
Okay, ma'am.
Okay, just take
Okay.
care of this muting and unmuting, both of you, Vinoda and Sandhya. Remaining
Okay,
people
ma'am.
don't touch. Remaining people don't touch with this muting and unmuting. Only these two people will be taking care of muting and unmuting. Okay? And Rubina will
Okay,
be
ma'am.
taking care of presentations.
Okay, ma'am.
Rubina is there, no? I think she's on 4, I think. And the remaining all program details you all know, isn't it?
Yes, ma'am.
So Rubina, you please be careful. ఒకసారి ప్రాక్టీస్ చేసుకుంటే బాగుంటదమ్మా. రుబీనా కూడా డైరెక్ట్ అక్కడ ఏమైనా ప్రాబ్లం అయితే ప్రాబ్లం కదా. ఇప్పుడు ఎవరు జాయిన్ కాక ముందు ఒకసారి ప్రాక్టీస్ చేసుకోమను.
హలో
అన్నపూర్ణ,
మేడం, ఇప్పుడు మీకు ఆమె వెల్కమ్ అది నోట్ ప్రిపేర్ చేయమన్నాను మేడం.
ఎందుకు ఇప్పుడా ఈ టైం కామా?
అంటే మనం ఓన్లీ ఇదివరకైతే ప్రాక్టీస్ ఓన్లీ చీఫ్ గెస్ట్ కే చేసాము, అదే విధంగా ఇప్పుడు చేసుకున్నాం మేడం.
ఒకసారి ప్రాక్టీస్ చేసుకోమని తనని.
ప్రీవియస్ గా ఆమె చేసింది మేడం, ఇప్పుడు బాగానే
अच्छा विनोदा 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 and సంధ్య
ఎస్ మ్యామ్ సంధ్య.
అమ్మ ఒక్కసారి యూట్యూబ్ లింక్ నేను షేర్ చేశాను కదా, అది మనకు వస్తుందా లేదా ఒకసారి చెక్ చేయండి.
ఓకే మ్యామ్.
చెక్ చేయండి ఒకసారి. అది అందులో మీరు పార్టిసిపేషన్ సర్టిఫికేట్స్ కోసం ఏదో లింక్ పెడతారు కదా, యూట్యూబ్ లో పెట్టండి, మన గ్రూప్ లో ఇక్కడ పెట్టండి, ఈ దీంట్లో ఈ చాట్స్ లో పెట్టండి, యూట్యూబ్ లో చాట్స్ లో కూడా పెట్టండి, రెండిట్లో పెట్టండి. ఓకేనా?
ఓకే మ్యామ్.
ఓకే చెక్ చేయండి. అది అందులో పార్టిసిపేషన్ సర్టిఫికేట్స్ కోసం ఏదో లింక్ పెడతారు కదా, యూట్యూబ్ లో పెట్టండి, మన గ్రూప్ లో ఇక్కడ పెట్టండి, ఈ చాట్ పెట్టండి, యూట్యూబ్ చాట్స్ లో కూడా పెట్టండి, రెండిట్లో పెట్టండి. ఓకేనా? ఎవరైనా యూట్యూబ్ ఓపెన్ చేసిన వాళ్ళు మ్యూట్ చేసుకోండి అమ్మా. సంబడి ఓపెన్ ద యూట్యూబ్, ప్లీజ్ మ్యూట్ ఇట్. అమ్మా బోత్ ఆఫ్ యూ లైక్ సంధ్య అండ్ వినోద ఎవరైనా జాయిన్ అవుతున్నారు అని అంటే కొంచెం నాకు చెప్పండి అమ్మా, ఓకేనా? అశోక్ సార్ 10:15 ఎగ్జాక్ట్లీ జాయిన్ అవుతానన్నారు, ఓకేనా?
ఓకే మ్యామ్.
ఆయన ఎవరైతే అట్లా జాయిన్ అవుతున్నారంటే ప్లీజ్ టెల్ మీ.
ఓకే మ్యామ్.
మ్యామ్.
చెప్పమ్మా. మొన్న ఆడిటోరియంలో అందరూ వచ్చేసారా పిల్లలు? వాళ్ళు జాయిన్ అయ్యారా?
Yes, ma'am.
అచ్చా శ్రీవాణి మీరేనా అక్కడ కాలేజ్ లో ఉంది? టిఎస్డబ్ల్యూ Okay, all of you, good morning.
Good morning, ma'am.
Those who want to respond or those who want to speak, they can come in front, okay? Near the computer, there's one computer there, no? So you can come there and speak if you want to. Whenever there is a need for you to respond, please come there and do. Okay, now? Or I think there's a phone or mobile phone also active, no? So mobile phone can be taken to the student who wants to respond. Sir, good morning, sir.
Very, very good morning, Dr. Nirupa.
Right, sir. Welcome to our National Science Day celebration, sir.
Thank you
We
so
are
much.
really privileged to have you, and it's an honor to have you on this dais.
Thank you so much.
We'll wait for 5 minutes, sir, so that you can have.
Okay, then. Absolutely, no problem. No problem.
To customize with all this thing. I just
Yes,
wanted to wait for 5 minutes
no,
and
no,
then start, sir.
Absolutely, there is no problem.
Okay, sir.
బ్యాకప్ మీరు పెట్టుకుంటారు.
హాట్స్పాట్ ఆన్ చేసి పెట్టాలా? దీంట్లో ఆన్ చేసి చూడాలనుకుంటున్నా. దీంట్లో ఆన్ చేసి పెట్టాను.
దాంట్లో మీరు కనెక్ట్ చేసి పెట్టుకోండి. ఇలానా ఇమీడియట్లీ పక్కదాన్ని దాంట్లో ఇప్పుడు ఇందులో మీ నెట్వర్క్ చూడండి.
2 రావాలి.
ఇక్కడ వాటిలో లేదా ఈ స్క్రోల్ చేస్తే కనిపిస్తుంది. ఆన్ అయి ఉందా ఫస్ట్ మీద?
బ్లూటూత్ కూడా ఆన్ చేయాలి.
బ్లూటూత్ అంటే మీది హాట్స్పాట్ కదా అది?
హాట్స్పాట్
హాట్స్పాట్
నాకు 2 సంబంధం లేదా? ఓకే,
సార్ ఆఫ్ చేసి ఆన్ చేయండి. మీరైతే కేబుల్ కనెక్ట్ అయ్యే ఉన్నారు కదా?
అవును. యాక్చువల్లీ ఇది యూజ్ కాదు, వైఫై లేకుంటేనే యూజ్ అవుతుంది.
అవును.
బాగున్నాయి.
Is everything ready, ma?
Yes, madam.
Can we start?
Okay, madam. Okay.
Sir, Ashok sir, is everything is ready now, sir? Can we start?
Yes, shall I start my lecture?
No, sir, no, sir, no. I
Okay.
mean, they will, sir. No, no, no.
Okay.
Okay, we will start from our side, sir. So if everything is okay, we'll start.
Yes,
That's fine, sir.
from my side, everything is okay.
Okay. Okay. Annapurna, carry on.
Okay, madam. Hearty welcome to one and all. Good morning, everyone. This is Annapurna Mamidala, lecturer in chemistry from TSWRDCW, Mahendra Hills. I cordially invite you all to the today's national webinar on chemistry. As you all know, today 28 February is celebrated as National Science Day all over the India. In order to commemorate the invention of Raman effect by Indian physicist Sir Chandrasekhar Venkata Raman on this day in the year 1928, for which he was awarded Nobel Prize in the year 1930. The day is celebrated with a particular theme. The theme for this year is Future of Science, Technology and Innovation, Impacts on Education, Skills and Work. The main objective of National Science Day is to bring awareness about the importance of science and technology in the community and to encourage people by popularizing the science and technology. At this juncture, I would like to quote few words of Sir C.V. Raman. If women of India take to science, they will achieve what even man have failed to do. Women have one quality, that is the quality of devotion. It is one of the most important passports to success in science. So all of us being a woman, we have quality of devotion in our DNA. So I request all the students to take to science and develop scientific attitude, observe the nature, have the habit of questioning and develop curiosity. If you ask the right question and the nature will open the door to her secrets, told by Sir C.V. Raman. With these few words, let's begin our today's national webinar. So it is going to be wonderful day. Today we have two wonderful speakers in the field of chemistry. Our chief speaker is Professor D. Ashok sir, UGC BSR faculty, Usmania University, who is working encyclopedia with vast research and teaching experience. And Professor Ashok sir will be dealing with the topic green and sustainable chemistry. Welcome, sir. We also have another wonderful speaker, Dr. G. Balakishan sir, Assistant Professor, Telangana University, who is young and dynamic with excellent research and academic profile. Dr. G. Balakishan sir will be dealing with the topic recent scientific innovations. Welcome, sir. I extend my heartful welcome and thanks to our beloved Secretary, sir, Supreme Swearer, Dr. R.S. Praveen Kumar, sir, IPS T. Swearis, who is a live example for continuous learning. And I would like to invite our Joint Secretary, Praveen Mamidala, sir, Head of Higher Education and DAR, who has been a motivation to our teaching and learning community. I also welcome our OST, Dr. Bhanu Prasad, sir, and our Zonal Coordinator, South Zone, Dr. Rajni ma'am, who have made their valuable presence in this event. Now, I gather words to welcome our beloved Principal ma'am, who has been a continuous encouragement and encouraging us to take up programs like this and directing us on this event, to conduct this event in a grand way. Welcome, ma'am. I welcome all the participants, faculty members, and young curious minds to this national webinar. Now I would like to invite our beloved principal ma'am to give welcome note. Welcome, ma'am.
Yeah, thank you, Annapurna, and good morning, everybody, and good morning to the honorable guest, Ashok sir, especially to very thank you for attending this webinar, sir. You have made our program and with your presence a very delightful event, and all of the students and everybody participants, thank you for joining this session. And we all know that today we have gathered here for celebrating National Science Day. And National Science Day is celebrated on February 28th every year across India, which is commemorating the invention of Raman effect by the great Indian physicist Sir Chandrasekhar Venkata Raman in 1928. For this contribution, he was awarded with Nobel Prize in 1930. By celebrating this day as National Science Day, we show our dignity and respect to the famous Indian physicist for his contribution in the field of science. So now it is on this occasion, we need to speak something about, we need to introduce, talk something about Sir C.V. Raman. The Sir C.V. Raman was born on November 7, 1888 at Tiruchirappalli in Tamil Nadu. His father was a lecturer in physics and mathematics. He studied at St. Aloysius Anglo-Indian High School, Visakhapatnam, and Presidency College, Madras. In 1904, he obtained a BSc degree from the University of Madras, where he stood first and won the gold medal in physics. In 1907, he completed an MSc degree at the University of Madras with highest distinction. From 1907 to 1933, he worked in Kolkata at the Indian Association for the Cultivation of Science, doing research on various topics in physics. On February 28, 1928, Raman led an experiment with Indian physicist K.S. Krishnan on the scattering of light when he discovered what now is called the Raman effect. Raman effect explains the effect on the scattering of light when passing through different materials. After his retirement, Raman established the Raman Research Institute in Bangalore. Raman passed away on November 21, 1970. The main objective of National Science Day is to bring awareness to people about the importance of science in our daily life and to encourage people by popularizing the science and technology. Every year, the day is celebrated with a particular theme, and this year, 2021, the theme is Future of STI, that is Science, Technology and Innovation, Impact on Education, Skill and Work. So Department of Science and Technology under Minister of Science and Technology, Government of India has released a draft of 5th National Science, Technology and Innovation Policy for public consultation. This policy is drafted to bring profound changes via short-term, medium-term and long-term mission mode projects by building a nurtured ecosystem that promotes research and innovation on the part of both individuals and organizations. So this theme, this webinar of ours, I hope this will give its contribution to the this draft 5th Science, Technology and Innovation Policy. And today, for this for a webinar for addressing all of gathering, we have two eminent personalities. And the first co-speaker is Professor D. Ashok, is a UGC BSR faculty and a senior professor in Department of Chemistry, OU, Hyderabad. So many of them who had a career in chemistry, who have made themselves a very good future in chemistry, they all know that Professor D. Ashok, and their career has been built up by in the hands of Professor D. Ashok. And I take this privilege to introduce him as my professor both in UG and PG level. And whatever is today is whatever part of career is there is being owed by Professor D. Ashok. So I heartily thank him for whatever his contributions are, for not only for people like me, but many of the students or many of the people who are in the career of chemistry. His contributions are there for their career development. So this this is a very great honor for me to introduce him to this session, and to my students and to my faculty. It's a great honor for me. And there's another another assistant professor, Dr. G. Balakrishan, is the second speaker of today, and HOD Department of Chemistry, Telangana University, Nizamabad. It's a great opportunity to have all these people, both the professors, to motivate our students and make our National Science Day celebrations a greater, to make our National Science Day a big event for all. Was I not audible all the time?
Now only, ma'am.
Okay. Right. So I now not wasting any of the much more time. I would like to introduce Dr. Professor D. Ashok Garu and to address our gathering. And before that, the introductory note for Ashok sir.
Good morning, Ananda. Welcome everyone. Thank you for joining us for today's webinar. I am Sandhya, faculty in chemistry of TSWRDC Mahendra Hills. It gives me immense pleasure to invite our chief guest, Professor Dr. Ashok sir, on the occasion of National Science Day celebrations. Ashok sir has 31 years of postgraduate teaching and 34 years of research experiences. Sir main interests are green chemistry, medicinal chemistry, and synthetic organic chemistry. Sir has published over 140 research papers, reputed national and international journals. Sir is a reviewer for reputed national and international journals such as Green Chemistry Letters, Review Synthetic Communications, Medicinal Chemistry Research, Current Medical Chemistry. Under his guidance, 18 students pursued their doctorate degree. He is leading a team of over 10 students for PhD and PDF programs. He has delivered invited lectures in national and international conferences, and also he has organized 3 national conferences in Osmania University. He has trained several young students in the art of organic synthesis and in turn working at prestigious R&D labs in India and abroad. He served as a registrar Telangana University, Nizamabad, and he is Vice President of Indian Council of Chemistry Sectional Committee member for Indian Science Congress in 2017. Presently, he is serving as a director in Directorate of Admissions in Osmania University. We are very fortunate to have here Ashok sir on this National Science Day. Now I welcome you, sir, to enlighten our students with your valuable words. Welcome, sir. Thank you. Over to you, sir. Thank you so much.
Hello.
Hello. Good morning, sir.
A very, very good morning.
Good morning, sir.
A very, very good morning.
Good morning, sir.
Good morning, sir.
Very, very good morning. Shall I share my screen? Very good morning.
Yes, sir. Yes, sir.
Sir, are you able to share the screen?
I think the host has to permit. Host disabled participant
Acha,
screen
correct.
sharing. Screen share చేస్తే
స్క్రీన్ అంతా షేర్ చేయాలంటే ఇది ఓన్లీ ఇది కదా.
ఇది పైన
ఓకే.
Hello.
Sir, is everything okay, sir?
Can you able to see my screen?
Yes, sir.
PPT?
Yes, sir.
Am I audible
Yes, sir.
clearly?
Yes, sir. Yes,
Okay.
clearly.
Shall I start?
Yes.
Sir.
A very good morning to you all. At the outset, I thank the organizers, especially Principal Dr. J. Nirupa, for inviting me to participate in National Science Day celebrations of Social Welfare Residential Degree College, Mahindra Hills. Well, I'd like to extend a very happy Science Day to all the participants. In fact, I'm very, very happy to associate with Science Day celebrations organized by Residential Degree College, Mahindra Hills. I'd like to congratulate the Secretary, Dr. R.S. Praveen Kumar Garu, Dr. Mamidala Praveen Garu, Joint Secretary, Dr. G. Nirupam Garu, Principal, Residential Degree College, Mahindra Hills, faculty, guests, students, and all the organizers. Why? Because today is very auspicious day. In entire country, teachers, students, scientists celebrating National Science Day with great enthusiasm. On this occasion, I would like to congratulate to all the participants for their interest towards science and towards Science Day celebrations. The success of any webinar depends upon the active participation of the participants. I hope all the participants actively involved in the celebrations of Science Day, a festival of science. Was there? One minute. On this occasion, I would like to share few details about science. Science is a supreme subject. Science is very, very important to us. Whatever the modern life which we are leading, mainly because of development in science. No doubt, technology is also there. But development of technology is based on this science. See, so many subjects involved in science, so many inventions were carried out in the science. All these are very much useful for us to lead a modern life, excellent life. On this occasion, I would like to congratulate all of you for being part of science. Science is a great subject, supreme subject, is a monopoly subject. You have to know what is science. Basic question. Science is knowledge gained by systematic study. Science is knowledge gained by experiment. Science is knowledge gained by observation. So with this, in brief, we can say that science is the knowledge which we get from systematic study, experiment, and observation. We can define science in different ways. Science is the intellectual and practical activity encompassing a systematic study of the structure and behavior of physical and natural world through observation and experiment. Here, I would look to pose a question to all the participants. As a science persons, we have to know one important point, that is important information about the science, that is, who is the father of science? Here, I'm showing this picture. All of you try to recollect father of science. Father of science is Galileo. Galileo's groundbreaking inventions and discoveries earned him the title the father of science. On every science day, it is our responsibility to remember the father of science, Galileo, and his work. Galileo was an experimentalist who, for the first time, linked a theory with experiment. And we have to know the importance of science. Why science is so important? How science is useful for the development of society. Science is valued by society because the application of scientific knowledge helps to satisfy many basic human needs and improve living standards. There are so many benefits of this science. That is the reason why you have to know about science. You have to know about scientific knowledge. Scientific knowledge is useful to develop new technologies, solve practical problems, and for the societal development, science is very much beneficial. New scientific knowledge lead to new applications. Therefore, my appeal to all young science students is make use of science to make your lives easier. Many scientists carried out a lot of work, lot of research in different fields of science and contributed a lot to the development of society. Therefore, it is worthwhile to remember at least some top scientists. I'd like to give, or I'd like to mention names of the few top scientists of India. Prafulla Chandra Ray, a famous academician, a famous chemist, founder of Bengal Chemicals and Pharmaceuticals, India's first pharmaceutical company. Salim Ali carried out a lot of research on birds. They call him as Birdman of India. You know very well about Srinivasa Ramanujan, a great mathematician known for his brilliant contributions to mathematical analysis, number theory, and continued fractions. And you know very well about Sir C.V. Raman, physicist, discovered Raman effect, and for his discovery, he got Nobel Prize in 1930. Homi Jahangir Baba, theoretical physicist, best known as chief architect of Indian Atomic Energy Program. Jagadish Chandra Bose, physicist, biologist, and archaeologist, who pioneered in the investigation of radio and microwave optics. Hargobind Khurana, biochemist, who won the Nobel Prize in 1968 for demonstrating how nucleotides in nucleic acids control the synthesis of proteins. Another famous scientist, Birbal Sahni, paleobotanist, known for his research on fossils in India. Subramanian Chandrasekhar, astrophysicist, won the Nobel Prize in 1983 for his research on evolutionary stages of massive stars. And you all know very well about APJ Abdul Kalam, known for his crucial role in the development of India's missile and nuclear weapons program. A quite number of women scientists carried out a lot of research and developed the society very much in different fields. It is worthwhile to remember a great women scientist of India, Asima Chatterjee, known for the development of antimalarial drugs. Paramjit Khurana, he developed all-weather seeds. He developed the strains of wheat and rice that are drought-resistant and withstand to heat, and by which he helped a lot to the farmers. Aditi Pant, a noted oceanographer, and was the first Indian woman to visit Antarctica. Tessie Thomas is known as the Missile Lady due to the successful launch of Agni series of missiles. Usha Barwali Chair, she produced India's first genetically modified food, the BP brinjal. Anand B. Joshi is the first woman doctor to practice Western medicine at the age of 21. At this juncture, I appeal all the young science students that try to develop science knowledge. I am very much confident that among you, there are many future scientists, future top scientists of India. All the very best to all of you. As we are celebrating a science festival today, that is National Science Day. National Science Day is celebrated all over India with great enthusiasm on 28th February every year in order to commemorate the invention of Raman effect by the Indian physicist Sir Chandrasekhara Venkat Raman. We call him as Sir C.V. Raman on 28th February 1928. On 20th February 1928, he has achieved Raman effect, which is very effective contribution, very useful contribution to science. Today, even though it is Sunday, they are celebrating Science Day. Even in different schools, colleges, universities, science institutions, students, teachers, scientists celebrating National Science Day. Remembering the contributions of Sir C.V. Raman, that is about Raman effect. In different ways, with the different banners, different ways people are celebrating. For his discovery, that is Raman effect, in the field of physics, Sir C.V. Raman was awarded and honored with the Nobel Prize in the physics in the year 1930. First Indian Nobel laureate in physics. It is a great achievement to India. It is not so easy to get Nobel laureate, Nobel Prize, but 1930 itself, when limited facilities were there, he did great work and got Nobel Prize. Little bit about Raman effect. When a beam of light traverses a dust-free transparent sample of the chemical compound, a small fraction of the light emerges in directions other than that of the incident beam. Most of the scattered light is of unchanged wavelength. A small part, however, has wavelengths different from that of incident light. Its presence is a result of Raman effect. In brief, Raman effect is change in wavelength of light that occurs when a light beam is deflected by molecules, which is a great work and it has a wide application. A few applications of Raman effect are: by this technique, we can generate fingerprint of universe. Raman spectroscopy is very much useful for analysis of material. Raman scanners are useful to diagnose diseased cells and organs. Raman effect is useful for the detection of explosives and also detection of drugs. One more important news about Sir C.V. Raman is, in 1954, he was honored with highest civilian award in India, in Bharat Ratna. Very few scientists were awarded this award. Sir C.V. Raman got this award in 1954. It is also a great achievement. Objectives of the National Science Day. The main objectives are to widely spread a message about the significance of science, to display all the activities, efforts, and achievements in the field of science, and to popularize science. A little bit about National Science Day celebrations. In entire India today, students, teachers, scientists are celebrating Science Festival, that is National Science Day. National Science Day is a science festival celebrated to promote scientific temper. The celebrations includes science exhibitions, public speeches, essay and elocution, poster presentations, debates, quiz competitions. In addition to these, in some schools, they're organizing visits to science institutions and science industries. Every year, Department of Science and Technology proposes a theme for National Science Day. Based on this theme, different science activities are organized in schools, colleges, universities, and institutions. This year, Department of Science and Technology has proposed a theme that is Future of Science, Technology and Innovation. Impacts on education, skills and work. On this occasion, I would like to give a small message to the young science students is students are future builders of India. Therefore, students must have a scientific temper. You have to know what is method of science and how to develop science. And you have to develop a habit to mold your activities accordingly. But this habit does not always come naturally. You have to be practiced. On this occasion, I would like to share some of the problems faced by our society, which I come across many times. And I thought that you young science students can able to solve such problems. Our society is facing some important problems. My appeal to young science students is to come forward to solve the problems of society, benefit of. A few examples I'd like to quote here. One, smoking is very important problem. Second, adulteration. Third, pollution. First about smoking. In rural area of Telangana and other states, many women involved in making BDs. In cities, many men and women are involved in making different cigarettes. See, speak how people are actively involved in making BDs. The manufacturers supply these BDs to different shops with nice labelings. And rural and city people are using these manufactured BD cigarettes. Like this, smoking habit is developed in different people, right from lower income group to higher income group people, including ladies in rural area. The number of cigarettes consumed by a smoking person is about 7,000 cigarettes or BDs per year. On every cigarette packet, we come across a quotation that smoking is injurious to health. But still, many people are consuming cigarettes. Here I would like to mention small data. About 25 lakh deaths worldwide was caused by coronavirus. 25 lakh people died due to coronavirus in a year time. Now we'll compare this with the how many people are affected by smoking and how many deaths happening per year. About 70 lakh deaths worldwide caused by smoking. We feel that coronavirus is very dangerous. Government has cautioned us, and we are taking a lot of precautions to control coronavirus. But see, more than this, people are dying due to smoking. Therefore, with this, what I can say is, smoking is more dangerous than coronavirus. Therefore, my appeal to all young science students is, educate the people and involve in how to control smoking. My personal opinion about smoking is, I may not find much fault with the smokers. I can say that the manufacturers, cultivators of tobacco are the main culprits for smoking. In rural area, many farmers growing tobacco. Government every year decides price for tobacco, means indirectly government encouraging to cultivate tobacco. Once tobacco is cultivated, then definitely using the tobacco, bidis and cigarettes are manufactured. Once these are manufactured, must be utilized. Therefore, people are using. But many people getting lung cancer by using tobacco, which is highly dangerous. Just now we have seen the data. The smoking is more dangerous than coronavirus. Therefore, my appeal is, we have to stop cultivation of tobacco. We have to stop manufacture of bidis and cigarettes. Governments encouraging women from rural area to manufacture bidis. They are increasing the making charges for them. Therefore, they are doing it. Once bidis, cigarettes are manufactured, somehow they must be used. Therefore, educate people, especially rural people, to stop cultivation of tobacco, to stop manufacture of tobacco, and educate the people not to smoke. Another important problem of society is food adulteration. Majority of the food items which we are consuming every day are not pure. In that, adulterants are present. Root cause for many health problems is adulteration. In olden days, people used to be very healthy. But now, right from youngsters to old age people are getting many diseases, facing many health problems. I can say this is mainly because of food adulteration. Food adulteration poses serious threat to health. in different ways. Food components are becoming impure. We say that fruits are very good for health. See, by injecting adulterating fruits, such type of adulterated fruits, if you consume, definitely your health is spoiled. Therefore, my appeal to all the youngsters is, as many food items are adulterated, you have to actively participate in how to reduce, control adulteration. For example, if you take honey, recently a group of scientists collected honey brands from market and tested. Out of 22 brands of honey sample picked from the market, 17 samples were adulterated. We consider honey is medicinal compound, very useful for our health. Out of 22 brands, 17 were adulterated. That means almost more than 90% of the honey brands are not pure. The common adulterants are sugar, glucose syrup, sugar syrup. Then what is your role? If you can able to educate people to check the purity, then we can able to control adulteration. To check purity of honey, what we do is dip a cotton ball in honey and burn it. If it burns instantly, then it is pure honey. Otherwise, it is not pure. It is very simple, easy to test. Or in a glass of water, put 1 tablespoon of honey. If it settles down in the glass, then it is pure honey. If it dissolves quickly, it is adulterated. Therefore, easily we can able to test whether a particular brand honey is pure or not at home. But many do not know how to check the purity. So as science students collect literature about how to check the purity of different food materials and educate the people, especially housewives, by which we can able to know given branded food material is pure or not, by which we can able to control. Now many are not taking whatever supplied, they're consuming. Therefore, the manufacturers are adding different adulterants for their financial benefits. Turmeric powder. Turmeric is very, very useful medicinal compound, cures cancer. Every day we have to consume turmeric. Even such medicinal compound is also not pure in the market. The common adulterants are chalk powder, lead chromate, and metanyl yellow. These are cheaper compounds. Therefore, they're adding these into turmeric. But we have to know how to check the purity. of turmeric powder. Add 1 spoon of turmeric powder in a glass of warm water. Don't shake or stir. If the powder settles at the bottom after 20 minutes, it is pure. If it gets dissolved, then it can be adulterated. Like this, easily, simply, without much expenditure, you can able to know particular branded turmeric powder is pure or adulterated. Red chili powder use every day to prepare curries. Even such powder, chili powder, available in the market is not pure. The common adulterants are brick powder and artificial colors. Easily we can check whether it is pure chili powder or not. Add a tablespoon of red chili powder in a glass of water. Stir well. If the particles are settled down, it can be brick powder. And if you see the color of water change to bright red, then it can be artificial colors. That is, the common adulterants are brick powder, which is very dangerous, and artificial colors are also very harmful compounds. Ghee. Most of the children every day consume ghee, or many sweets. Sweets are prepared by ghee. The common adulterants of ghee are vegetable oil, starch, and vanaspati. Easily we can check the purity of ghee. Melt a tablespoon of ghee and pour in a glass jar and refrigerate till it becomes solid. If the layers are separated, then the ghee is impure. That is, we can able to test whether it is pure or not. Even milk that we are getting is not very much pure. The common adulterants are unhygienic water, chalk powder, soap powder, starch, hydrogen peroxide, urea, by which there are so many harmful effects of these adulterants: food poisoning, heart problems, cancer, vomiting, nausea. Like this, there are so many harmful effects if you consume such type of milk. Most of the children and old age people every day consume milk to maintain good health. Because of these adulterants, by consuming such milk, they are going to get so many harmful effects. Easily we can able to know whether milk is pure or some adulterants are present in it. By taste also we can able to know. Natural milk is slightly sweet in taste. The synthetic milk is bitter. If you see the texture, no soapy feeling if rubbed between fingers. If it is synthetic milk, we get soapy feeling if rubbed between fingers. By heating, the milk remains white. But if it is synthetic milk, turns yellowish when boiled. If urea is present, by a small test, we can able to know. Like this, so we can able to identify adulterants. If starch is present, by adding iodine, we can able to get the color. Like this, so many food items available in the market are not pure. Even if you take tea, used tea leaves, processed and colored, that we purchase. It is already used. If we consume such type of tea powder, liver disorders happen. Like this, many food items available in the market or adulterated coffee powder, sugar, salt, pepper, jaggery, pulses, sugar, coriander powder, cloves, cumin seeds, rava, black pepper, coconut oil, cinnamon, bajra, common salt. Even common salt is chalk powder is added to common salt. Then what you have to do is dissolve in water. The water turns white, then it indicates the presence of chalk powder. Papaya seeds are added to black pepper. Like this, society is facing a lot of problem, health disorders because of adulteration. So my appeal to all of you is try to collect the literature about how to test, how to spot adulterants present in food materials, and give wide publicity about how to perform, how to check impurity present in it. If you do this in every family, then we can able to control the adulteration by which we can able to maintain good health. In addition to smoking and adulteration, one more important problem is faced by society, that is pollution. This is the major problem faced by entire world. Environment is polluted in villages, towns, cities, states, countries, and continents. Everywhere environmental pollution problem is. Therefore, today I have chosen green and sustainable chemistry, which helps us to control the pollution. Therefore, today's topic about my lecture is green and sustainable chemistry. Before this, I would like to mention a little bit about chemistry and its importance. Chemistry is king of all science subjects. Chemistry plays an important role in science. Different subjects of science very much associated with chemistry is a big part of our life, everyday life. We start the day with chemistry. For brushing, we use paste. For bathing, we use soap. They are made up of chemical compounds in which chemistry is involved. The clothes which we wear are made up of chemical compounds in which chemistry is involved. The food we eat, the milk, snacks, bread, fruits, vegetables, all these are made up of chemical compounds. Chemistry is involved. In cooking, chemistry is involved. In digestion of food is involved. Our body is made up of chemical compounds. All the body parts made up of chemical compounds. Number of chemical reactions, biological reactions takes place in the body in which chemicals are converted into some other chemicals. Without chemistry, life is not possible. Chemistry plays an important role in our lives. Chemistry is heart of our society. It has multiple applications, useful applications to society. Therefore, it plays an important role, especially the drugs made up of chemicals used to cure different diseases. Nowadays, lifespan of people has increased compared to olden days. This is mainly because of development of new drugs. Drugs means again chemicals in which chemistry is involved. Therefore, we can say that chemicals for better life, chemistry for better life. Whatever the modern life, better life which we are leading today, mainly because of development in chemistry. Quinine, a well-known compound, a well-known drug used for the treatment of malaria, is the chemical compound. For the past 400 years, this chemical quinine is in use to control malaria. Nobicin is an antibiotic. We consume antibiotics to cure different diseases. Irinotecan, drug used for the treatment of cancer, is a chemical compound. Bivalsant drug, a new drug, recently FDA approved this. This is used for the treatment of high blood pressure. Like this, chemistry plays an important role in the development of society in different forms. We are using chemistry in our daily life. With this, what we can understand is these examples clearly show us that there is a lot of scope of chemistry in the development of mankind, which is a constructive development. But there is a destructive development, that is, by manufacturing different chemical compounds, the environment is very much polluted. The environmental pollution, air pollution, water pollution, land pollution, sound pollution, etc. What is meant by pollution? Contamination of the environment with harmful substances is called pollution. Now, environment is very much polluted by different people, including chemists. Therefore, we have to know, as a chemist, we have to know how to control environmental pollution, how to reduce pollution, because environmental pollution is also very, very dangerous, highly harmful. Health of human beings and animals will be very much affected by environmental pollution. Therefore, it is high time to know how to reduce environmental pollution. For example, air pollution. Contamination of the air with harmful substances is called as air pollution. Major source of air pollution is chemical industries. In spite of strong conditions, chemical industries polluting the air. People living nearby industries are very much affected. See how industries polluting the air. A lot of smoke is coming from industries, by which air is very much polluted. The health of human beings, animals, very much affected by air pollution. Then water pollution, contamination of water with undesirable substances, which make it unfit for usage, called water pollution. Water pollution is caused by chemical industries, industrial waste, and effluents discharged into rivers and sea, by which water is very much polluted. River water, sea water is very much polluted. See how effluents from industries are added to water. water pollution, sea water pollution, water pollution. You may say that what I'm telling may not be totally true because government taking a lot of measurements to control water pollution. Now see this slide. This news appeared in TV news on 25th February 2021. Just 3 days back, this news has come. River Ganga, very much polluted. A person into Ganga river to collect water. It's supposed to be very clean, but there is a lot of pollution in Ganga river. See how the water is polluted, Ganga water is polluted. Therefore, with this, what we can understand is, in spite of powerful, strong conditions, people are not caring, and there is a lot of pollution in rivers, in sea, and in tanks. Therefore, it is high time to control environmental pollution. Then another pollution is about water pollution. Because of water pollution, we are getting malaria, typhoid, etc. Aquatic life gets destroyed, because in water many fishes and other animals will be there, that much affected by pollution. About 10% of deaths worldwide are caused by water pollution. Then another pollution is land pollution. Industries will dump a lot of unwanted material on different places, by which ground is very much affected, groundwater is very much affected. Industrial waste is dumped at different places, by which groundwater is very much affected. Now here I would like to pose a question. Is it only industries that are responsible for such scenario? Is it only industries polluting the environment? No doubt industries polluting the environment. How much percentage may be different? But my question is, in addition to industries, others also polluting the environment, especially universities, colleges. Teachers and students from universities and colleges polluting the environment. How? By performing different experiments at college level, university level, environment is very much polluted. I'd like to give one example for environmental pollution. Teacher students are following the same old experiments, procedures for doing their practicals. Many of these experiments involve toxic chemicals like liquid bromine, benzene, carbon tetrachloride, etc., which are not at all safe to human health. I can say that in most of the colleges, universities, for the preparation of para-bromoisotonilide from estanolide, even today using bromine in glacial acetic acid. Bromine is very toxic chemical. Liquid bromine is very, very toxic, harmful. We are not supposed to use. But still, by using the same old procedure in most of the colleges, universities, using bromine. Now I will tell alternate method after some time. Therefore, one important point I would like to inform to all the students is, if you do not protect the environment, at least do not pollute the environment. Most of the people unable to protect the environment. Once it is polluted, it is difficult to control. But at least do not pollute the environment. That they are not being, instead polluting the environment very much. Now we are taking very light, very easy, not bothering about the pollution. But in future, if same situation continues, there is a lot of problem with the pollution. Forthcoming situation, that means after 50 years, situation will be such that environment will be very much polluted if same situation continues. For oxygen purpose, we may have to carry a plant to get oxygen. If I tell this, you may not believe, but the fact. 20, 30 years back, no one purchased water. Now, almost every family in villages and cities purchasing mineral water. Similarly, after 50 years, we may have to buy oxygen cylinders, or we may have to carry a plant along with us for oxygen purpose. Otherwise, it is very difficult to survive. Therefore, my appeal to young students is, think about it and try to involve in how to control environmental pollution, which is possible by educating the people. Educate the people. Tell about the pollution, problems of pollution. Then somehow we can able to control. Everybody should feel responsible to control this. Otherwise, it is not so easy to control, because it is the problem of all the countries. Be a part of the solution, not the pollution. Right? Try to find out the solution to control pollution, but not to the pollution. Environmental protection has become a global concern. It is a global problem, not a local problem. Every village, every town, every city, every state, every country, every continent, in entire universe, environmental protection problem is there. Environmental pollution is there. Therefore, it is global concern. Understanding the responsibility, chemists are searching for environmental benign strategies, eco-friendly strategies for future sustainable growth. There were chemists doing a lot of research about how to control environmental pollution. One of the thrust areas for achieving this target is use of green chemistry. Why? Because green chemistry looks at prevention of pollution. Our main objective is how to prevent pollution, which we can do with the use of green chemistry. What is green chemistry? What is definition of green chemistry? Green chemistry is utilization of set of principles that reduces or eliminates the use or generation of hazardous substances to health and environment, the design and manufacture and application of chemical compounds. Therefore, in the manufacture of chemical compounds, drugs, and different articles, we design and we carry out to manufacture. But during this, we generate so many compounds. which should not be hazardous to health. Therefore, there are some principles that reduces or eliminates the use or generation of hazardous substances. By following those principles, if we perform the reactions, we can reduce or eliminate use and generation of hazardous substances. Therefore, with this, in brief, what we can say is, in any chemical reaction, we are not supposed to use hazardous substances. We are not supposed to generate hazardous substances. In case if you generate hazardous substances, there is a lot of problem for society. After a few minutes, I will tell how the hazardous substances will affect the society very well. Sustainable chemistry, a scientific concept that seeks to improve the efficiency with which natural resources are used to meet human needs for chemical products and therefore, now we will discuss a little bit about green and sustainable chemistry. Why we need green chemistry? Why? Because it looks at prevention, and which is extremely important area of chemistry. Therefore, we are supposed to know about green chemistry, green and sustainable chemistry. We are supposed to implement green and sustainable chemistry in our daily life. Paul T. Anastas from Austria carried out a lot of research on green chemistry and framed 12 basic principles of green chemistry. As Paul T. Anastas carried out a lot of research in green chemistry, for which he earned the title that father of green chemistry. Paul T. Anastas, father of green chemistry. The 12 basic principles formulated by Paul T. Anastas are prevention of waste, atom economy, less hazardous chemical synthesis, design safer chemicals, safer solvents and auxiliaries, design for energy efficiency, use renewable food stocks, reduce derivatives, catalysis, design for degradation, real-time analysis for pollution prevention, inherently safer chemistry for accident prevention. Like this, Paul T. Anastas and his group framed 12 basic principles. By following these principles, if you perform any reaction, then it becomes green synthesis. Synthesis carried out by using green principles is called as green synthesis. I would like to mention few principles which we come across in our laboratory, where we have to adopt these principles. Prevention of waste. One important principle of green chemistry. We know when a substrate reacts with substrate S reacts with a reagent or product is formed, sometimes byproduct is also formed. Or in most of the cases, waste byproduct formation takes place. In academic laboratories, we perform the reactions by using small quantities, whereas in industries, products are prepared in large quantities, quintals of tons of products will be produced, where the waste products obtained also in very, very large quantities in tons of waste product formation takes place. Then question arises is how to dispose this waste. If waste is disposed in atmosphere, air is polluted, sea or river, water is polluted, land is polluted. then where we have to dispose? And the cost involved in the treatment or disposal of waste adds to the overall production cost. Therefore, this is very, very important principle. Most of the industries facing this problem about disposal of waste produced every day. United States of America industries expenditure on treatment and disposal of waste is approximately 120 crores per hour. In 1 hour time, US industries are spending 120 crores simply for disposal of waste, not to perform the reactions, just to dispose waste produced in the manufacture of different drugs and products. That means disposal of waste is very costly affair, not so easy to dispose. Then what they will do is the cost of disposal will also be added in the cost of the product. Then what is the remedy? What is the solution for this problem? Because every day a lot of waste is produced, and where we have to dump? Question arises. There must be some remedy. You know, prevention is better than cure. If you prevent the disease, is better than curing disease. Similarly, if waste is not produced, disposal concern does not arise. Therefore, how to prevent the formation of waste is important. For which what we have to do is carry out the synthesis in such a way that formation of waste is minimum or absent. No waste at all. Therefore, whenever you perform a reaction, first try to understand critically, are there any possibility of getting waste? Then perform practically in different techniques by doing research and carry out synthesis of such compounds in such a way that there is no formation of waste. Another principle is atom economy. What is atom economy? The maximum incorporation of the atoms in the reactants and reagents into the final product is called as atom economy. It is an important principle. Why? Because if all the atoms of reactant and also all the atoms of reagent involved in the formation of product, then there is no byproduct and there is no waste. Therefore, we have to carry out reactions in such a way that in which atom economy is 100%. One example I would like to quote. We know Diels-Alder reaction in which a diene reacts with a dienophile by which product formation takes place. This reaction is 100% atom economy reaction. Why? Because all the atoms of diene and all the atoms of dienophile present in the product. If all the atoms are involved in the formation of product, the product question does not arise. Formation of waste does not arise. Then another important green principle. By this principle, we can understand the importance of green chemistry and the importance of green synthesis. And we can understand why we have to know green chemistry, why we have to follow green synthesis. Let's hazardous chemical synthesis. Methyl isocyanate, MIC, is a poisonous gas. It is extremely hazardous to human health. Very dangerous, harmful compound. It was the principal toxicant involved in the Bhopal tragedy. Union Carbide industry present at Bhopal, involved in Bhopal tragedy. On 2nd December 1984 night, I can say at midnight, because industries work 24 hours. At midnight of 2nd December 1984, there was leakage of methyl isocyanate poisonous gas from Union Carbide industry. No doubt industry people take a lot of precautions, measurements, but sometimes the controls may fail. Therefore, the methyl isocyanate gas was leaked around midnight of 2nd December 1984. When this gas mixed with air, air is very much polluted. Those inhaled very much affected. Human beings, animals, birds who inhaled such polluted air very much affected, by which many people died in the sleep itself. Lakhs of people died by inhaling methyl isocyanate during sleep. See the situation. That is, many people died by inhaling polluted air, having contaminated with methyl isocyanate poisonous gas. The Bhopal gas tragedy of 1984 affected over 5 lakh people. By one incident, 5 lakh people were affected. Therefore, now try to understand importance of the pollution. And the pollution is very, very dangerous. If pollution is less, you may not feel, but it is just like slow poison. After few months or years, our health will be affected. If any leakage is there from industries, immediately so many people will die. That is that when recently in Vizag also, there was some leakage by which some people died. Therefore, pollution, what is pollution? Contamination of air or water or land with harmful substances is called as environmental pollution. Even today, those who survived but suffering with the chronic illness, about 1,20,000 people, residents, suffering from chronic illnesses because of Bhopal tragedy, inhaling methyl isocyanate on 2nd December 1984. See the effect. Even after so many years also, about 36 years also, people are suffering from illness. Therefore, what is the solution? It is better to develop such a synthetic route in which hazardous substances are not produced, not involved. If hazardous substance is not produced, then such type of tragedies will not happen. Therefore, for the synthesis of a product, there will be so many alternative methods, alternative routes, alternative procedures. Therefore, in every reaction, in every manufacture, you have to know what is the mechanism involved, what are the intermediates formed, what is the nature of intermediates, whether they are poisonous or not. All those you have to verify. In whichever route the poisonous products are not involved or not formed, that route is better. You have to find out such route. This is about the green principle. Then another principle is safer solvents and auxiliaries. This is also very, very important. We are supposed to know. In every reaction, we are habituated to use some solvent. The solvent used for the particular reaction should not cause the environmental pollution, should not cause health. But whatever the salts which we are using in our practical laboratories are hazardous. Even today, in many colleges and universities, teachers, students are using harmful solvents such as benzene, carbon tetrachloride, etc. They are highly carcinogenic. To perform some physical particles, carbon tetrachloride is used. To perform some organic reactions, benzene is used. But these are very, very dangerous, highly harmful. Benzene is such a carcinogenic solvent. If you inhale for 2-3 minutes, your lifespan will be reduced by 2-3 weeks. In most of the foreign laboratories, benzene is not used at all. If it is required in small quantities, it is poured away from the main laboratories, because which is very, very dangerous. Even in our AC cars, just whenever you switch on for the first time in a day, some benzene is released. In traffic area, if you calculate benzene percentage in air, which is very much higher than permitted percentage in Hyderabad, Delhi, Mumbai, Chennai, etc. Therefore, if you travel in Hyderabad during daytime, definitely you are going to consume some amount of benzene, which will affect your health because it is highly carcinogenic. Many people are getting cancer because they are inhaling such harmful substances. Therefore, what is the alternative? Try to use alternate solvents. Try to avoid benzene, carbon tetrachloride, etc. Alternate solvents. Use water to perform reaction. Use ethyl alcohol to perform reaction. Organic liquids. All these are green solvents. Use these solvents by which you can able to reduce the pollution. Because in academic laboratories, after performing the reaction, you simply evaporate the solvent. Then what happens? That solvent mixes up with the air, by which the air is very much polluted, but the air we are going to inhale, by which our health is affected. Then if you use alternative solvents, the green solvents, then there will not be any problem. Or alternative method is one more alternative method is there. Better not to use any solvent. Perform reaction without using any solvent. Here question arises is whether it is possible to perform a reaction without using solvent. Most of the reactions which we perform by using solvent. Some liquid solvent we use, benzene, carbon tetrachloride, chloroform, etc. But if you don't use solvent, then this solvent pollution will not come across. Then question is, does a reaction proceed without a solvent? Is it possible to perform a reaction without using a solvent? Long back, Aristotle stated, no reaction proceeds without solvent. Aristotle says that some solvent must be used to perform a reaction. But in 1905, Adolf von Baer proved that without using solvent also we can perform the reactions. He has synthesized indigo without using any solvent in 1905, for which he was awarded with the Nobel Prize in chemistry. Therefore, with this, what we can understand is the solvent-free synthesis is nothing but green synthesis, nothing but green chemistry. Green chemistry already known in literature, but it is not much in use. But now there is a lot of environmental pollution, therefore it is better to use green chemistry. Therefore, with this, what we can understand is best solvent is no solvent. Without using any solvent, if you perform the reaction, it will be very efficient and economic, because we are not going to purchase any solvent. And it is environmentally benign synthesis, because we are not going to evaporate the solvent. We are not going to contaminate air. But if you use the solvent, you have to purchase, you have to incur some expenditure. And afterwards, the air is very much polluted by performing the reaction using solvent. Therefore, best solvent is no solvent. My appeal to all the youngsters is, whenever you want to perform a reaction, try to carry out the reaction without using any solvent. Without using any solvent, just by mixing reactant reagent and grinding in the laboratory, it is possible to perform the reaction. You will get the product. No solvent is used. But we are habituated to use liquid solvent and we are habituated to reflux it. There are many reactions which can be carried out without using any solvent, just simply by grinding technique, by mixing the reactant reagent, even if they are not liquids also, even if they are solids, by grinding technique, we can able to prepare the products in good yields. I would like to give some examples. To aromatic amine, if you add aromatic aldehyde, ship-base formation takes place. Simply, this you can try at your laboratory. Take aniline and add benzaldehyde, grind it for some time, then you will get the ship-base. No need to add any solvent. No need to heat. Just in few minutes, simply by grinding, you will get the product. In our synthesis or research also, we have performed so many reactions without using any solvent. For example, a dichalcone on treatment with silica, with the sodium hydrogen sulfate, under microwave radiation conditions, product is formed. That is cyclized product is formed. Here, no solvent is used. That is, without using solvent also, it is possible to carry out reactions. Here, I have given some solvents. Use of these solvents. In laboratory, we come across so many solvents. Some are preferred solvents, some are somewhat better usable, and some are undesirable. For example, you can use water, acetone, ethanol, ethyl acetate, methanol, etc. These are not much harmful. Water is very safe chemical, green solvent. But cyclohexane, heptane, toluene, etc. are not preferred, but if it is essential, you can use it, not much harmful. But there are some solvents which are highly safe, undesirable. Pentane, hexane, diisopropyl ether, diethyl ether. Diethyl ether used in the laboratory. Chloroform used in the laboratory. Dimethyl formamide, carbon tetrachloride, pyridine. Right? If you go to any laboratory, of college or university where you come across carbon tetrachloride, pyridine, chloroform, etc. Therefore, we should avoid these solvents. Then another principle is design for energy efficiency, conventional heating. Generally, we perform the reactions by heating, Bunsen burner, oil bath, heating mantle are used for heating purpose. The alternative method we have to use, because conventional heating is not favorable. Why it is not favorable? Because when you want to supply heat to reactant reagent, first we take reactant reagent in an RB flask, we place this in oil bath and we put Bunsen burner. First we heat oil bath, then oil is heated, then RB flask is heated, then heat is transferred to the solvent. Then when solvent is heated up, then heat is transferred to reactant and reagent present in the solvent mixture. Therefore, here our aim is to supply heat to reactant and reagent, but unnecessarily we are heating oil bath, oil, flask, solvent, etc. Once the reaction is completed, whatever the heat given to all these will be waste only. Therefore, with this, what we can say is, in this method, we have to heat solvents, operators, etc. Afterwards, they will cool down. Double energy penalty without any apparent benefits. Therefore, alternative energy sources are by microwave radiation, by using microwave ovens. You know, nowadays many people are using microwave ovens for heating purpose at our residences. Such microwave ovens can be used, or somewhat industrial microwave ovens can be used. Ultrasound radiation can be used to perform reactions, or under sunlight also reactions can be performed. Among these, generally, microwave irradiation method is used, which is far better than conventional heating with Bunsen burner or mantle. Microwave irradiation method is fast reaction, fast. Conventional method is slow. Energy consumed is less under microwave, and energy consumed is more in conventional method. Because in conventional heating, heat is transferred from oil bath to oil to flask to solvent, etc. Under microwave radiation directly passes to the starting materials and reactant reagents, by which effect will be more. Homogeneous heating will be there, by which reaction can be performed. There are many advantages for microwave radiation. It is economic, high yields are obtained, very selective, fast, high purity product is obtained, and above all, it is eco-friendly. The main difference is under microwave radiation, homogeneous heating will be there, therefore fast heating will be there, reaction is completed very easily. Whereas in classical heating, heat is transferred by preheated molecules, by which time required will be more. See this reaction. In two different test tubes, reaction is performed. One is by using microwaves, another is by using oil bath. Microwave radiation directly passed on reaction mixture, by which outer layer, inner layer, total mixture is affected, converted into brown colored, dark brown colored product. But under conventional heating, oil bath heating, heat comes from walls of the test tube. Therefore, nearer to walls of the test tube, brown color is there because of heat is transferred first to the molecules nearer to walls of test tube. In the middle, still blue color is there because heat is not supplied and the reaction is not full. Therefore, time required will be more under conventional heating, oil bath heating, Bunsen burner heating, mantle heating. Whereas by using microwave radiation, heating is very fast, yield is small, time required is very less, and there are many examples available. By this, you can tell many things about green principles. But Theoretically, you can tell anything, but unless experimental evidence is there, it is not possible to believe. Science means it is experimental subject. Therefore, now I will give you some experimental examples by which you can able to understand the importance of green chemistry. For example, if you take Claisen rearrangement, allyl phenyl ether, when heated in presence of N-dimethyl aniline, converted to orthoallyl phenol. This is Claisen rearrangement. This is, in this, all the atoms of reactant participated in the product. Therefore, it is 100% atom economy reaction. N-dimethyl aniline is solvent which is required back. Just we are supplying heat. That's therefore here, or we can carry out reaction and microwave radiation also. But here, what you have to observe is whatever the atoms present in allyl phenyl ether, all of them are present in the product. Therefore, all are present in the product. There is no byproduct. There is no waste. Therefore, this is prevention of waste or 100% atom economy. Selection of solvent. We are under impression that by using water, organic reactions may not be performed. Generally, we use organic solvents such as benzene, ethyl acetate, chloroform, etc. to perform reactions. But this example clearly indicates that reaction can be carried out using water also. This is Michael addition reaction of thiophenol in chalcone, thiophenol to chalcone. The chalcone is treated with thiophenol. Some surfactant is used, potassium carbonate, water. No organic solvent. Just by adding water, reaction takes place. Michael addition takes place, by which 98% product is found. So with this, what we can understand is it is possible to carry out organic reactions by using water, green solvent. Water is a cheap solvent, abundantly available. It is not harmful. Therefore, easily we can use water as solvent. Alternatively, we can use ionic liquids, which are salts of organic compounds, semi-solids, not harmful, green solvents. By using chloroaluminate 3 ionic liquid, Middlecoff's reaction was performed. In this acylation taking place, monostyl naphthalene is obtained. Here, ionic liquid used as solvent. In 5 minutes time, reaction is completed. And here there is no harmful solvent. Therefore, it is a green synthesis. Solid support synthesis. Just now I said that it is possible to perform the reaction without using solvent. Simply we have to absorb reactant reagent on some solid support, just like silica gel, alumina. Here aldehyde and ethyl acetate first absorbed on silica gel and irradiated with microwave radiation, by which dihydropyridine derivatives. Therefore, here no solvent, because simply absorbed on a particular adsorbent and heated. By using biocatalysts, enzymes, also we can perform the reaction. Even we can perform the reaction selectively. Ethyl acetate on reaction with Baker's yeast, converted into S alcohol, S configuration containing alcohol in 61%. Here, in starting material, 2 C-double bond O groups are there. One is in ketone, second is in ester. Ester also C-double bond O group is there, C-double bond OET. Normal reactions, if you perform the reaction, both the C-double bond O groups can be reduced. C-double bond O of ketone and C-double bond O of ester. But by using Baker's yeast, selectively ketone is reduced to alcohol, but not like the select reactions are very selective, and by using catalyst, if you perform the reaction, it is very easy to perform the reaction, and no need to use solvent, no need to heat up. Another reaction, Claisen-Schmidt reaction. Ketone on reaction with aldehyde, just by treating with KOH in the presence of ethyl alcohol. By heating under microwave, within 5 minutes, alcohol formation takes place, product formation takes place. Or this you can try at your laboratory, BSc laboratory. Take aromatic ketone and add aromatic aldehyde and add required KOH. Grind it. Just if you grind for 5 minutes, you will get yellow colored product. There no solvent is required, no heating is required. Like this, we can perform the reaction. All this clearly shows that it is possible to carry out green reactions in our laboratory. This is another reaction under microwave radiation. See, yields are very high. Aldehyde is converted to acid plus alcohol in the presence of water and alumina. No solvent, only microwave radiation. In 15 seconds, just in 1/4 minute, reaction takes place. Same reaction, if you want to carry it by normal conventional method, it takes 3 to 5 years, hours. And here, see the yields: 97% yield, 100% yield. Like this, high yields are obtained. Instead of microwave radiation, we can use ultrasound also. By using ultrasound, also Kranz reaction is performed, by which acid plus alcohol are formed, and yield is 100%. So all this clearly indicate that it is possible to carry out reactions at our BSc, MSc laboratories, also using green synthesis. This is not a reaction of diene, anthracene, and dienophile malic anhydride, by which corresponding adduct formation takes place. Anthracene malic anhydride adduct formation takes place. This preparation is there in MSc previous syllabus of MSc Organic Chemistry, for which in majority of the universities, colleges, they are using old procedures by conventional method to prepare this product, adduct. Students, teachers are spending 4 to 5 hours. But see, under microwave radiation, in 1 minute time, with 80% yield, product formation takes place. See, compare conventional method 4 to 5 hours. Under conventional heating, 1 minute. Very fast. Easily, reaction takes place by using green synthesis. Ultrasound assisted synthesis of this sort of reaction. Here also it is very fast, and yield is 99 to 100%. The conventional method, such high yields are not formed, are not obtained. Williamson synthesis, phenol or derivative of phenol on reaction with alkyl halides in the presence of base, sodium hydroxide, water. Under microwave radiation, alkyl ethers are formed, alkyl aryl ethers are formed. Here yield is 88. The time required to perform this reaction is 1 minute. Please note the time required. By normal method, it takes 3 to 4 hours, but in just 1 minute time, within no time, you are going to get the product. Similarly, Diekmann reaction under microwave radiation, in one part, in one step itself, 2-benzyl furan 3-ol formation takes place in 97% yield. Just now we have discussed about the bromination of parabromo acetonylate. Even today, in most of the colleges and universities, for the preparation of parabromo acetonylate, using liquid bromine, which is highly corrosive. But alternative methods are there. Department of Science and Technology appointed a task force to find out alternative green procedures. They have suggested that the same reaction can be performed using silicon nitrate and potassium bromide in place of water. Therefore, in this, the corrosive bromine is replaced by novel brominating reagent, silicon nitrate and potassium bromide. And reaction is carried out in aqueous medium water. There were no organic solvent, no harmful bromine, no corrosive liquid bromine is used. With this, we can perform the reaction. Silicon nitrate is available in our laboratory, potassium bromide is available. We can perform this type of reaction by which we can avoid the pollution. Then dill salt reaction is performed by using benzene, solvent, and reflux. But the same reaction can be performed by using water at room temperature. Therefore, like this, dill salt reactions can be performed by using water. Therefore, in this, the toxic benzene solvent is avoided and there is no heat required. Just at room temperature, reaction is performed. By using sunlight, we can perform photochemical reaction. This ketone, benzophenone or benzophene derivative is converted into benzophenool. Therefore, here safer chemicals are used and the renewable source of energy, solar energy, is required. Therefore, there is no heating and solar energy is available abundant. Just if you put under sunlight, the reaction can be performed. And this is another reaction. Normally, it takes 240 minutes at heating at 120 to 120 degrees centigrade. 240 minutes means very large amount of time. But if you irradiate the same reaction mixture under microwave, then in 5 minutes time, reaction is completed. The conventional method, 240 minutes. Under microwave radiation, 5 minutes. Compare the yields. Compare the timings. Right? Therefore, under microwave radiation, you can perform reactions easily. Within no time, the product formation takes place. This reaction we have performed in our laboratory. When metanaphthalate is treated with ferric chloride, water under reflux, we get this vinyl compound. But here, we are heating. Instead of heating, just by grinding, also we can get this product. We have tested in our laboratory. I personally carried out this reaction by adding few drops of water. Just by grinding for a few minutes, the product formation takes place. Therefore, it is possible to carry out organic reactions by mechanochemical method, that is grinding method, by which easily reaction can be performed. This is another reaction. This preparation is there. 7-hydroxy-4-methyl-coumarin preparation is there in MSc previous practicals. Even today, in many universities and colleges, they are using old procedures, that is resorcinol treated with ethyl acetate in place of concentrated sulfuric acid at 0 degrees centigrade. No doubt 7-hydroxy-4-methyl-coumarin is formed. But in this, corrosive sulfuric acid is used. Sulfuric acid is very dangerous compound, really harmful compound. Now we will see the green procedure, alternative procedure. In place of concentrated sulfuric acid, if you use K10 clay, K10 clay is cheaper clay available abundantly. Instead of concentrated sulfuric acid, K10 clay acts as acid and reaction is performed. Therefore, in this, use of corrosive sulfuric acid is avoided. where this product is found. Without using corrosive sulfuric acid, you can perform the reaction. Like this, if you search in literature, there are so many examples of green synthesis. It is high time to follow green principles, to follow green synthesis for the preparation of different compounds in laboratory, in research laboratories. And whatever you develop in research laboratories, the same thing will be implemented in industries. Therefore, my appeal to all youngsters is, as far as possible, it is better to use green synthesis in your laboratories. Like this, there are so many examples available. You can go through with the literature. At the juncture, I'd like to stop. But my appeal to all of you is, all of you take a pledge that whenever I perform the reaction, I will use green synthesis, green technology, green method, by which I can able to control environmental pollution, reduce environmental pollution, and help the society. It is a great help to society. Whenever you find time, please visit Arts College of Osmania University, which is 100 years old university. Finally, my sincere thanks to Dr. R.S. Praveen Garu, Secretary, Dr. Mamidala Praveen Garu, Joint Secretary, and Dr. G. Nirupa, Principal, Mahindra Hills Residential College, faculty, guests, students, and all the organizers for inviting me to deliver a talk on the occasion of National Science Day. My very special thanks to all the participants for your active participation and making the National Science Day celebrations a grand. Thank you and all. At this juncture, I would like to thank the funding agencies. UGC has awarded me BSR Faculty Fellowship even after retirement, and Department of Science and Technology, CSIR, provided funding for our research. Thank you one and all. And if you have any questions, you are most welcome.
Thank you, sir. Thank you so much for your sir. It was amazing. And the way you have done with the Bhopal gas incident, everything has come in our vision. And next thing is green chemistry. Now we have I think all the students, they will get to know about new projects and all. They will they can actively now participate in performing new projects and all, and going back to getting new solvents and all. Quite interesting. Thank you so much. Now I take a minute for the students, and if you have any questions, please post them to sir. Any questions from the audience or any questions from the participants? It is your time now.
This is Jayalakshmi from So is there any percentage of carbon dioxide? Hello. Good afternoon, sir.
Hello. Very good afternoon.
Good afternoon, sir.
Tell me.
This is Jayalakshmi from
Very good
BZC,
afternoon. Tell
sir.
me.
Nowadays,
me.
carbon dioxide percent in the atmosphere is increasing, sir. Is there any chemical process to reduce carbon dioxide percent?
Yes, because there are many green procedures available, and government implementing many green procedures to reduce carbon dioxide, and especially we have to grow plants so that the plants can get carbon dioxide and can take the carbon dioxide and release oxygen, because we require a lot of oxygen now. Therefore, it is better to grow plants as many as possible at your college, at your residence, at every place.
Okay, thank you, sir. Good afternoon, sir.
Very good afternoon. Tell me.
This is Pooja from BZC third year, sir. My question is, nowadays petrol rates are very high, sir, and also
Yes.
petrol gives more pollution.
Yes.
If there any other alternate fuel is there for petrol, sir?
No, the alternative fuels are there, but they're costly. Only thing is, we have to use pooling method. Because now, if you observe, if you see the cars, on an average, if you see 1 or 2 persons will be there in each car. Instead, the pooling method may be used, or we have used public transportation. 10 people are there, they're using 10 cars. Instead, 10 people can travel in one bus. The pooling method must be used, public transportation must be used. The petrol cost means the cost will be definitely increased because of various reasons. And one more thing, after 2 years, petrol may not be available also. Cost is one aspect, but if it's not available, then it is a big problem. Therefore, definitely alternative procedures we have to find out, and we have to reduce usage of petrol, because it is obtained from at the crust. If it is exhausted, we cannot do anything. That is the reason why we have to minimize usage of the petrol. Even youngsters using so many bikes, it is not required, right? Even for the small distance also, many youngsters are using the bikes, therefore, which is not advisable. Therefore, one alternative is we have to reduce usage of petrol, by which we can reduce the environmental pollution. And a lot of research is going on alternative methods, but the cost affair is important. If it is more costly, then it is of no use. That is the problem. Therefore, the better to reduce usage of petrol. Okay. Hello. Hello.
Yes, sir. Yes, sir.
When electric cars also available, but it is costly affair.
One more thing, sir. There is like when it comes to this, sir, am I audible?
Yes, audible. Yes.
Audible, no?
Yes.
Yeah. The one more question is the single-use plastic nowadays. You know, like they are asking about they are banning the single-use plastic material.
Yes.
So, in what way? Like, I mean, we have. Is there any alternatives to such things in? Because those are all daily life active. We need them more and more. So, what sort of things can be done so that this plastic can be altered or something like that? Is there any such signs?
Actually, without using plastic, it is very difficult to survive. You can use plastic, there is no doubt at all. But the only thing is, the harmful plastic we are not supposed to use. For example, polythene bags, which we are using, or which used by vendors, is not practical, and it is not useful, and it is harmful. Such type of plastic must be avoided. Otherwise, because in place of metals, we are using the plastic items, the plastic materials, which are very much cheaper than metals. Such type of things are not harmful. But wherever the plastic is harmful to us, such harmful plastics must be avoided. But that we are not doing. Why we are not doing? The main defect is such type of plastic materials should not be manufactured. Simply, police people putting penalty on small vegetable vendors for using plastic bags. My question is, why we have to give penalty to vegetable vendor? Government should not allow the manufacturer to produce plastic bags which are harmful. Not government is permitting, people are producing. Once produced, must be utilized. Therefore, the government should impose very strict rules and high penalties should be there for the manufacturer. Right? If not manufactured, usage question does not arise. Everybody use alternative bags or cloth bags we can use. But we are not using cloth bags. Why? Because the vegetable vendor giving plastic bags. Why? Because many plastic bags are available in cheaper method. Right? Therefore, alternatives are there. But everybody should feel responsibility. Right? Now, so many participants are there. How many of us are using cloth bags when we go to market? All of you question on yourself. Right? Therefore, if you stop using it, then automatically pollution is reduced. Alternatives are there. But only thing is, we have to take responsibility, for which we require some lectures, some awareness programs, etc. Therefore, my appeal to young research students or young science students is give a lot of awareness. First, you don't use such type of plastic bags and don't allow your parents, relatives to use such type of bags. If everybody take oath and everybody take it as challenge, and definitely nobody will use plastic bags. If nobody uses plastic bags, then manufacture question does not arise. Right? Therefore, everybody should take responsibility for the development of society to eradicate environmental pollution. Because plastic bags are highly, highly harmful. Because they are not biodegradable, very dangerous. Okay?
Yes, sir.
Yes.
Right. Any other questions, please? We'll have his number, and I hope sir will be giving his mail ID or phone number also. If we can share it when it is possible to you with the with permission of Ashok sir.
Yes. You can give my mail ID. They can pose a number of questions.
Yes.
Mail me a number of questions. I am prepared to answer.
Yes. So any other questions at all? Suppose if you're getting it at a later stage from now, you can always ask him, or you can always reach him for his for clarification of any of your doubts. Okay. And one more thing is there are some forms and all also. Just see to it. All the participants, please see the forms also. Now, thank you, sir. Thank you for this session. Now I want thank session for Ashok sir. Please, one of the
Thank you, sir, and thank you, madam.
Connect here.
Yes, ma'am, go ahead.
Hello. Hello, sir. I am here to present oath of thanks to you, sir.
I think there's some connectivity issue with Annapurna.
Madam, I'm here.
Yeah. Go ahead, no?
Okay, ma'am. Thank you, ma'am. And thank you, sir. I'm here to present oath of thanks to Dr. Ashok, sir. On behalf of TSW or DCW Mahendra Hills, I would like to thank you, sir, for accepting our invitation and encouraging our students with your valuable insights on the problems faced by present society and applications of green chemistry and sustainable chemistry on this fine occasion of Science Day. As you said, whatever luxury comforts we are enjoying today are all are the applications of science and technology only. And thank you, sir, for making us and our students to recollect the great eminent scientists from Prafulla Chandra Ray to Dr. APJ Abdul Kalam, and moreover making us to know about our own women scientists like Asima Chatterjee, Paramjit Khurana, Aditi Pant, Tessie Thomas, Usha Banwale, Anandi Bai Joshi. Thank you very much, sir. And thank you, sir, for encouraging and appealing our students to come up with solutions for the problems in the current society like smoking, adulteration, and pollution. And thank you, sir, for letting us to know about how to find the different adulterants in our daily uses, things like honey, milk, chili powder, etc., milk. And finally, with all these vast introduction, you have taken us to the subject of green chemistry. Thank you very much, sir. Really, it was very interesting and very informative. And you made us to know the importance of green chemistry and sustainable chemistry with giving a lot of examples. Thank you for explaining us the 12 principles of green synthesis in a very lucid manner with examples, and also explaining us the different ways of green synthetic approaches like biocatalysts, solid support synthesis, ionic liquids, microwave assisted reactions, ultrasound assisted synthetic reactions. Uh, Thank you very much for providing very good insights into green chemistry. Thank you very much, sir. Sir, it would be better if we include this green chemistry in any one of our UG curriculum. Already we are having in the new syllabus for third year, that third semester, we have this microwave assisted synthesis of aspirin. Only demo is there, sir. In the final year, if you include that green chemistry and sustainable chemistry as a part of general chemistry, that will be helpful to the students and to the society also. They will get involved and get to know the things what is actually the green chemistry is.
Yes.
Sir, please look into that, sir.
Sure.
With this small suggestion, from the bottom of heart, I would convey thanks to you, sir. And your encouragement to our college is very much, sir. It is better to have a direct interaction than this virtual interaction.
Yes.
Actually,
Yes.
we wanted to have a live session with you, sir. Our students are very much excited to see you, sir.
Thank you. Definitely in the future, I will come to your college, and deliver offline session certainly. And it is better to keep few green synthesis practicals.
Sure, sir.
It's
Sure.
the final year. For that also I will try.
Note down all those reactions and we will try to practice in our lab, sir.
And thank you very much for this vote of thanks.
Thank
And I would like to thank Sandhya for introducing me to the audience. Though I may not deserve so many things, but you said very well about me, spoke about me. And a special thanks to Dr. Nirupa, my own student, for inviting me to participate in Festival of Science, that is Science Day celebrations 2021. Thank you very much, Dr. Nirupa, and all the organizers, faculty, etc. Thank you very much. Thank you.
Thank you, sir.
Thank you, sir. Thank you so much for
Thank you.
coming. In spite of your busy schedule,
Thank you.
and it's quite motivating all our students. Thank you so much, sir.
Okay, thank you.
So there is one more section now.
Yes, yes, sir.
Professor Dr. Balakrishan Garu is going to give us start his session now.
Okay.
So
Ma'am, now I would like to invite Manasa to introduce about the Dr. G. Balakishan sir, our next speaker, about recent scientific innovations.
Good afternoon, ma'am, and good afternoon, research person, Professor Dr. Balakishan sir. And this is C. Manasa, working as lecturer in chemistry at TSWRDC Mahindra Hills. First of all, a very happy National Science Day to all. And it is my great honor and pleasure to introduce Assistant Professor Balakishan sir. Sir is working as assistant professor and head of the department in the Organic Chemistry Telangana University main campus, Dichpalli, located at Nizamabad. Sir is chaired as BOS chairperson from the year 2018 to 2020. And presently, three PhD students are working under his supervision and one project fellow carrying out research work under his provision at his research lab. And sir received Associate Fellow Award from the Telangana Academy of Science. He delivered several lectures in national and international seminars and in workshops also. Sir, he bagged an early career research award from DST SEP. He invited as a jury member by Honorable District Collector for Inspired Telangana State Level Exhibition 2015. And Sir also worked as a scientist in a research and development laboratory, Penn Biochemicals, Hyderabad. Sir has completed 2 postdoctoral doctor fellows under respectively in the year 2013 to 14 under the supervision of Professor Piyush Kumar, Cross Cancer Institute, University of Alberta, Canada. And one more was from the year 2010 to 12 under the guidance of Professor Uzama Marako, Organic Chemistry Laboratory, School of Pharmacy, Kinki University, located in Japan. He has published 16 research articles in national and international journals, and Sir also has 6 USA patent rights in different streams. And we are glad to have Sir Stock and so lucky to have get a chance to interact with Assistant Professor Balakishan sir. Our young minds will get more knowledge after Sir's seminars. Thank you, sir. Now I request Dr. Balakishan sir to deliver a wonderful seminar. Sir, please continue the section. Thank you, sir. Hello. Hello, sir. Welcome, sir.
Yeah, thank you for your nice introduction about me. Yeah. Can I have my screen share?
Yes, sir. Yes, sir.
Yeah. Okay, are you able to see my presentation?
Yes,
Yeah.
sir.
So, thank you so much for your wonderful opportunity to share on this occasion of Science Day First of all, I would like to thank the principal of Mahendra Hills College, TSWRDC, for inviting me to share my research thoughts in front of you. And also I want to express my sincere gratitude to Dr. R.S. Praveen Kumar sir, who is a dynamic leader and leading these institutions wonderfully. And I like him and loved him because of his dynamic leadership, which so many people are attracted towards and take him as a model to live like him. I am also one among them. And also I express my sincere thanks to Dr. Mamidala Praveen sir. So he is from our university only. Now he is working as a joint secretary in your institutions. He is also a wonderful guy and very active. And in Telangana University, he did so many good things. So I like him. So I am very happy to share my research thoughts to you this afternoon. And also, I am very privileged to speak on this occasion along with my teacher, Professor D. Ashok. So I used to learn subject from him in Masterminds Coaching Center. I think in 1997, I think. So I used to learn from him from Masterminds Coaching Institute. He is a very good teacher. I learned so many basics and organic chemistry from him. I thank you. I thank Professor Ashok sir. And let me start my presentation, recent scientific innovations. Yeah, my presentation contains. So firstly, I'm going to give you a small introduction about my presentation. Afterwards, I'm going to explain about emerging trends in scientific research. And just a minute. Please, do you allow me to record my session?
Sure, one more thing.
Is it already recording?
Yes, sir, it is.
Principal ma'am?
View it in the YouTube also. It will be there as it is.
Pardon?
You can also record also. And one more thing is we have it in the live session, sir. We are recording it on YouTube. So you can always view it later on also.
Okay, thank you.
I'll share the link of the YouTube to you. And
Yeah.
the chat session also. Whenever you would like, you can always use this link to view your things, sir.
Okay. Okay. After that, I'm going to give you information on targets for drug design and discovery, so which belongs to my research area. And finally, I would conclude from these important topics: emerging trends in scientific research and targets for drug design and discovery. So both are very, very important to understand and to learn these concepts if you want to go for higher education and if you want to go for research areas in your future. Okay, so already you know about science, the importance of science. Okay, science is an essential element. Essential means without science, it is not possible to live or exist on this earth. I think so. Therefore, I consider it as essential element in daily life in the world today. Okay, so in world, everyone directly or indirectly using or experiencing science in their lives. So therefore, I can say this statement that the basic knowledge of science is mandatory for all. So in olden days, people may aware of science or not, it was over. It was no problem for them. But I think nowadays, or from these days onwards, everyone must understand, should have basic knowledge of science to understand life and all the things happenings around us in this world today. Because why I am making it is mandatory for all, because it makes life easier and rapid and open our mind in many ways. Okay, so because of science, the fruits of science we are experiencing in our daily life, which makes our life easier. You can take n number of examples. Okay, and also it makes us rapid life where we are experiencing all the things rapidly, instantly, many things. Not so in the olden days. If you want to talk to your neighbor or relative, or if any friend, you have to wait for some time to contact them. But nowadays, it is not like though. It is not like so. So we can immediately, with the fraction of seconds, we can communicate anyone on this world, right? So that's the way I can say science makes life easier and rapid. We're moving rapidly. We're getting so many things instantly. And also science makes our minds open in many ways to understand many things which are happening around us and around the world. Okay. And also I can tell you that science is completely based on facts. It's not a myth. They are not myths. Okay. Science always based on facts and experiments, right? Of course, initially they may come with proposals or theories, but after that they can make experiments and prove them. Okay, so whatever we have scientific knowledge and scientific technology and scientific research, all are there. All of them are based on facts and experiments. Okay, so without experiments, we cannot accept in science. Okay, so therefore, basic knowledge is remains same. In science, basic knowledge is remains same. Okay, it cannot be changed. So therefore, I request and I suggest all the students and the teachers who are participating in this presentation, everyone must have the idea of basic knowledge of science. It is inevitable. Okay, without science, we can go like a blind person. I can say that. So therefore, science is very, very important subject to learn all the people on this world. At least you should have minimum basic knowledge about science. Okay. You know what science makes us? That gives us wings to our imaginations, right? So we can imagine our futures. We can imagine our upcoming things, great things, which are going to be discovered with the help of science. Okay, so therefore, if you are interested towards science, it gives you to wings to imagine your life as well as world's future. So that much important subject of science. On this occasion, I am very proudly say that science is very essential subject for all. I can declare that. Okay. One more thing I want to suggest to you, all the students and graduates and teachers and the participants. Nowadays, interdisciplinary or multidisciplinary research is becoming very, very essential and very important. In olden days, it was okay to have one specific subject knowledge and live on this earth. But nowadays, everyone expecting interdisciplinary research, interdisciplinary subjects. Okay, it is, you cannot say that I am okay if I study only one subject in my life. No, that will not be okay in future. Okay, so if you want to learn the chemistry, you should also have the minimum basic knowledge of biology as well as pharmaceutical chemistry. Okay, so that's what I mean to say that interdisciplinary research is becoming more and more important day by day. So my dear students, I suggest you, please concentrate and learn the subjects as much as you can, not only single subject. Okay, so that is very, very important for your future. If you skill in at least allied subjects as well as chemistry. So emerging trends, I am going to explain some wonderful things which are happening in this world recently. Okay, so these are the according to my opinion, these are some emerging trends in scientific innovations, right? First thing, have you ever imagined artificial intelligence can be applied in chemistry? I don't think so. Okay, so but the good news is artificial intelligence is able to apply in chemistry to turn the chemistry research drastically. Okay, because you know nowadays artificial intelligence is making a lot of boom for many students or many unemployed graduates to get wonderful jobs on that artificial intelligence. Not only in chemistry, in most of the fields, artificial intelligence is becoming one of the greatest wonder to change their destiny as well as their subjects research. So that much important, my dear friends. Artificial intelligence applied is able to apply to chemistry. In 2020, there are many number of research articles published and many number of research labs concentrating artificial intelligence chemistry research, that is called Chem Intelligence. Okay, so I'm going to explain you about that wonderful discovery in my next slide, from next slide onwards. The next one I'm going to explain you about dual ion batteries. You know, nowadays we're using lithium ion batteries, right? They are wonderful discovery. Okay, for that the scientists got Nobel Prize for that on that research. Okay, so nowadays we are using smartphones. In smartphones we are using lithium ion batteries and more, and we are getting latest updated batteries which can increase the number of hours charging and which can have more number of or more capacity of storages. Okay, so they are very, very important. And next thing I'm going to explain about high pressure inorganic chemistry. Okay, high pressure inorganic chemistry also one of the latest technique which brings a lot of benefits to the society as well as humankind. And next I'm going to deal with macro monomers for better plastic recycling. Okay, so I came to know that recently, previously, some people posed a question to Professor Ashok sir regarding plastic alternative. Okay, so I think the research on plastic recycling is going more and more, and they're coming with number of good ideas and experimental results, so that I can say in future the plastic recycling methods can be arrived and they can be influence a lot of things. And next I can say microBMA and bioactive compounds, which is also very upcoming and emerging trend in 2020 research, in chemical research as well as scientific research. And also I'm going to give you some information on nanosensors. Okay, and they can be very useful in many ways. And also rapid diagnostic for testing, rapid diagnostics for testing. Okay, so it is also very, very burning and important area. So we can see in the next slides. And also one of the important emerging trend, RNA vaccines, vaccination. So nowadays we're observing that world is scaring about so many number of viral diseases. Okay, for viral diseases, to solve that problems, the research in RNA vaccination is may give the wonderful solutions for that kind of problems. So these are the emerging trends. Of course, there are many number of emerging trends, but I selectively choose these emerging trends which can be so useful and which can illuminate your minds with this presentation, I hope so. Okay, so please concentrate on my lecture. Don't be move here and around, and try to listen carefully. I hope you will experience wonderful information on these trends. First, let me explain you about artificial intelligence for chemistry. We thought that artificial intelligence only for computer systems or computer and technology and engineering, but it changes also. Artificial intelligence can also be useful in chemical research, in scientific research. How it can be useful for chemical and scientific research, artificial intelligence? Because when I go through some literature about this topic, I have found so many research articles found that they are being used more and more by chemists to perform various tasks. Okay, originally research in artificial applied to chemistry has largely been fueled by the need. What are the needs? To accelerate drug discovery and reduce its use costs and the time to market for new drugs. Okay, you know, till now, with all our science and technology and all the advancements for the last year, we can be able to discover a drug, a suitable drug, an effective drug. It takes at least 10 to 15 years of time. 10 to 15 years of time from beginning to get the FDA approval and to release the market. It's a huge time, you know. Nowadays, people don't want to wait for that much time. Okay? They want to get whatever they want instantly and immediately. So that's the society changes. That's the changes occurred in the society. So for that, artificial intelligence can give the solution to accelerate the drug discovery. And also, you know, if you want to discovery or if you want to release a drug from beginning to end, it costs a lot of billions of money. Okay, that's why pharmaceutical companies scared to design or release drugs for viral diseases, because you know what happens in viral diseases, virus can change or modify its structure. So if you design a drug for the particular virus, and if it modified that structure, that drug may not be useful for that. Okay, so after spending a lot of money, billions of money in that particular drug, if that virus modified its structure and changes its mechanism, then everything goes into vain. So therefore, this is the one of the biggest problem in viral drugs, antiviral drugs discovery. So solution for that, artificial intelligence can reduce the cost hugely. Okay, reduce the cost. You may get cheaply, because artificial intelligence gives us lot of information, properties, and mechanism of action, and how the binding interactions of drug, and all the information can be gives by artificial intelligence, so that we can be effective in drug designing and discovery. So therefore, it accelerates the drug discovery, and also it reduces the huge costs, and also it can help to release the new drug into the market immediately. Okay, those are the advantages of artificial intelligence. So which is going to drastic changes in our future research work, right? Artificial intelligence has made significant progress towards the acceleration of drug discovery in research and development. Okay, it has already made significant progress in R&D research work. Okay, therefore, I challenge all the students and teachers and graduates. You can think of this artificial intelligence for your future research and higher education to solve many problems which are facing by world today. Okay, this is the one of the best area to choose your higher education and research work to make wonderful contribution to the scientific community. Okay, so however, the applications of artificial intelligence in chemistry are not limited to drug discovery. It can be expanded to many areas, right? So I can say The people are saying this is chem intelligence. Okay. Whenever artificial intelligence uses in chemical research or in scientific research, that can be considered as chem intelligence, right? So this is the term I liked, because in future you are going to hear again and again about this term, chem intelligence. So what chem intelligence can do to our research, in chemical research and scientific research? Okay, first of all, it is very useful to predict molecular properties. Okay, so initially what happens in the olden days, in the traditional days, what happens, it takes a lot of time to predict the molecular properties of a particular drug, particular chemical substance or molecule. But with the help of artificial intelligence, it gives us a lot of information about properties of that particular molecule. That means structure activity relationships also can be derived from artificial intelligence without further moving in our research work. Initially, you can get those kind of information. Therefore, our drug design is very effective. It cannot be go in vain because it is more targeting, I can say. Then molecule design. Okay, so nowadays we are having molecular modeling studies and in silico docking studies and computer aided drug design. All these techniques we are using in the laboratory, scientific laboratory, to design a suitable molecule for a particular drug. Okay, but for your kind information, I want to give you the latest information that artificial intelligence gives us very information on molecular design. So binding interactions, about active site of molecular targets, and about the size, and about the bondings takes place, and all those wonderful information can be given by artificial intelligence. Okay, and also artificial intelligence is useful in retrosynthesis. What is retrosynthesis? Retrosynthesis is a synthetic approach by which you can making simple starting material by breaking the target molecule. So all the steps and chemicals you can design scheme in retrosynthesis. Suppose, so from molecular modeling studies and in silico drug design information and computer aided drug design, you get some information about the designing a molecule. Okay, so once you getting the designing a molecule, you can come to a conclusion with the lead molecule. So when you come to the lead molecule or the target molecule, so you need to analyze with the retrosynthesis to draw the synthetic scheme for that target molecule for organic synthesis. Okay, this kind of work also done by artificial intelligence. Is it wonderful? It is, when I heard these kind of things, I'm so excited, and I'm so excited to share my thoughts in front of you this afternoon. So Chem Intelligence is going to rock in future research work. Reaction outcome predictions. Okay, Chem or artificial intelligence can help us to get what kind of byproducts and what kind of enantiomers and other products along with the target molecule. So that kind of information also is possible with the artificial intelligence. Okay, next, reaction conditions predictions. Okay, so with the artificial intelligence, it gives us n number of methods to synthesis a particular intermediate, a target molecule. Therefore, it saves a lot of time for us, okay, in research work. And also chemical reaction optimization. Artificial intelligence gives us and helps us in optimize the reaction conditions. What are the temperature and pressure and number of hours, okay, all those things can be optimized, and how to get the good yield, how to modify the substituents and the reagents, okay, those kind of information also can be given by artificial intelligence. What a wonderful things we are going to have in the future research. Therefore, these are the wonderful benefits in chemical research and scientific research from artificial intelligence. So it is going to play a key role in our research work, so that the time and the cost and the safety of a drug can be released very instantly or immediately. Okay, so next I'm going to explain you about another area, which is a recent emerging trend in dual ion batteries research. Okay, because everyone is using smartphones. Not only smartphones, they are using a lot of gadgets. Okay, they require batteries for energy storage. Okay, the world is running with the gadgets only. So there is a lot of requirement and importance on this area. Okay, so presently the lithium ion batteries are doing wonderful storage devices, but in that lithium ion batteries, the material used is cobalt and lithium sources. Okay, so you know, for our vehicles we are using petrol, right, and diesel. So what happens nowadays, we are getting some shortage of petrol and diesel. Okay, so therefore people are now seriously thinking and doing research alternative to the petrol and diesel in the same way. So that is the natural product. In the same way, the lithium sources and the cobalt, if the sources as becoming day by day less, so we need alternatives, right? Because this is the largest requirement for world, because everyone is using. Therefore, dual ion batteries research brings wonderful things in future. Okay, it can develop the energy storage technologies apart from lithium ion batteries. Okay, because day by day world is demanding renewable and sustainable energy sources. Okay, because they should not be toxic. They should not be harmful to the mankind on this earth. There is a lot of demand for renewable and sustainable energy sources. This kind of demand can be solved by this research, dual ion batteries, right? Because this is going to be emerging energy storage systems. Okay. So one of the research finding for alternative for lithium batteries. So they are taking graphite as both electrodes and a combination of organic solvents and lithium sulfur as electrolytes. So that is the idea behind dual ion batteries. Okay. So with them, so they are going to be successful in their research work because it is fascinating. It's high working potential because these kind of batteries are more efficient than lithium batteries. That's what we required. Okay. And potentially high energy densities, high safety and low cost. So these are the wonderful benefits of dual ion batteries research. Okay. So this is the burning and emerging trend in chemical research as well as scientific research, my dear students. So therefore, you can think in this area and you can imagine how our world is going to change in future. Okay. So these are the wonderful things going to take place in near future. And one more emerging trend I'm going to explain about high pressure inorganic chemistry. You know, till now, we have so much of limitations and restrictions, and sometimes we cannot synthesize some kind of inorganic compounds with our facilities and technologies. But by using high pressure, so there is many new inorganic compounds can be synthesized which are not possible earlier. Okay. The field of high pressure synthesis research may have great breakthroughs in the next few years. My dear students, you can imagine or understand, because what is the use of high pressure? Just I give you some information and also logic behind high pressure inorganic chemistry synthesis. Because you know, the molecules, the atoms, they occupy a lot of space in gaseous state, okay, and also in liquid state. So if they want to react with each other, they should come together, okay. So the distance between them is to be very less. They should come nearer to each other. They should touch with each other. Okay, they should rub with each other. Then there is a possibility of reaction takes place. Okay, high pressure provides such kind of distance and such kind of ineffective molecular interactions can be possible with the high pressure. Okay, so already n number of research articles are published to synthesize some very important inorganic chemistry materials, which can be so useful in our daily life. Okay, So what is the importance of inorganic chemistry materials? They can be very useful in mankind life. They can be as materials, okay? So such kind of importance is there. So it can be a very bright area in near future. The future development of high pressure synthesis can become more and more growing. Okay, so therefore you can, this is these kind of thoughts, these kind of innovations or creativity makes makes many things possible which were impossible in previous days, in olden days. Okay, therefore, so these emerging trends may bring so many breakthroughs in future research area. Chemistry may have solutions to our plastic trash problems. Okay, how? So generally, plastics are synthesized by the chemicals polyethylene, high density and low density polyethylenes, polypropylene, polyethylene terephthalate, polyvinyl chloride, polystyrene, etc. Okay, these are the compounds, chemical compounds and polymers uses in the plastics. Okay, so what is the idea behind trash this kind of problem? The idea, several companies have started up to capitalize on these processes. What is the process? They wanted to break them into monomers of that polymer, particular polymers. Okay, so actually, what is the biggest problem we are facing now? Because of plastic, which is not decomposable easily in earth, so it would be like that only for years and years together. Therefore, so much of nature changes will occur, and also floods will come out, and also earth will not give crops. Okay, many danger situations are there with the problem of plastic decomposition. So, but the solutions, they are doing research for these problems. So they are creating some microbes, some bacteria, microbes to decompose the plastic into its monomers, into its simple molecules. It is a wonderful idea, and some research is going on that. Okay, so the building blocks, okay, some methods return plastic to their monomer form. Once it converted to its monomer form, that can be freshly used again for another material. There would not be any loss, and as well as we can decrease the pollution. Okay, so those are the wonderful benefits with this research work. Okay, so chemistry may have solutions. Okay, chemical research, scientific research, I hope can give solution to this kind of problems of plastic. And the next wonderful area we can discuss about microbiome and bioactive compounds. Microbiome and bioactive compounds. As you know, the human body is the trillions of microbes are exist in our human body. Okay, there are two kinds of microbes. Okay, so there is harmful microbes and there are useful microbes. Okay, so useful microbes, what they do, they can release some bioactive compounds so that with that bioactive compounds, the harmful microbes can be killed and they can be sent out from the body. Okay, so therefore, this microbiome and bioactive compounds research area is growing, is becoming important and very useful. Okay, so therefore, what in this microbiome and bioactive compounds research can contribute to the world? So, as you know, as I said previously, human oral cavity, in gut and skin have been shown abundant and diverse microbial communities in our body. Okay, so they produce small bioactive molecules and peptides which can interact and inhibit the bacteria and modify their growth, and they can kill the bacteria, and they can boost our immunoresponse. Okay, therefore, if you understand about that mechanism, and if you understand what kind of bioactive compounds and peptides released from microbes, if you are able to understand them, you can use those bioactive molecules as a drugs. Okay, and they can be very useful, and they can be very safe, because that kind of bioactive molecules already working in the body by releasing the useful microbes in the human body. Okay, so the idea behind this microbiome and bioactive compounds, they gives us very important information to the research, and scientists, so that those kind of bioactive molecules can be synthesized in the laboratory and they can be used as drugs. Okay, as soon as possible. So that is the one of the another emerging trend in the research work. And nanosensors, it may be chemical sensors or mechanical sensors. Okay, they can be chemical sensors or mechanical sensors. So what they do, they detect various chemicals in gases for pollution monitoring. Okay, so nowadays all are bothering about the pollution. Okay, even governments and even the world also scaring about the pollution. Okay, because pollution is growing more and more, and all the scientists, many scientists proved that very soon it may become so dangerous to the mankind. Okay, so therefore it is very important to us to learn about how to reduce the pollution. So in that way, nanosensors will be very useful. Okay, nanosensors can predict the various chemicals in gases and also in pollution. Once we understand about the chemicals, then we'll get the solution how to decompose that chemical or how to inactivate that chemical in a particular gas or in a pollution area. Okay, and also nanosensors can be useful for medical diagnostics purposes. Okay, sometimes nanosensors can be introduced in the blood, and they can be introduced as a nano chip into the body, and it gives us clear information about the problem inside the body. Okay, So therefore, nanosensors are going to become wonderful things in near future. And also it can be useful for in monitoring physical parameters like temperature and displacement and flow. Okay. And also it is very useful to monitor plant signaling and metabolism to understand plant biology. Okay. So yeah, many uses we have with the nano sensors. And also it can be it is useful to study neurotransmitters in our brain, to understanding about neurophysiology. Okay. So therefore, so in near future with this research, so we are going to achieve so many great things, I think so. Therefore, my dear students and teachers and graduates and participants, think in these burning and emerging trends, okay, to opt as a research and to as a higher education in your education. And rapid diagnostics for testing. This is also wonderful research area and emerging trend. You know, nowadays, last year, all the world suffered from lockdown. Okay. We closed everything and we stayed at home with a lot of fear and threats because of coronavirus. Okay. So coronavirus. So wherever you go, so wherever you see on the media, wherever you see on the media, everywhere coronavirus, coronavirus. Okay. All are scared about coronavirus. Okay. So we need rapid diagnostic tests for that. You know, this research developed a rapid test for coronavirus. So because of that, actually, to diagnose a problem with our laboratories and laboratory procedures, it takes a lot of time. In olden days, it takes sometimes days, number of days. But nowadays, it is not possible to wait for that much time. We need instant result, instant diagnosis. So this is the solution, research solution given by chemistry to the mankind to understand, to know about the coronavirus disease, whether a person affected with coronavirus or not, how we are able to diagnose rapidly. Because of this research area, because of these rapid diagnostics test, this gives us result within 5 minutes to 20 minutes, which takes place about number of days in olden days. What a wonderful research we have in scientific research. So therefore, whatever the problems, whatever the threats getting around the world, so the research innovations gives solutions for that. Remember that. So therefore, I encourage you, I inspire you, I illuminate you, I provoke you that go for a research, because I request even governments also to provide sufficient fund for the research, so that the research may not be go into vein, of course, it gives so many solutions for our problems which we are facing today. So one more thing, I want to explain you about RNA vaccines. So this is also emerging trend, I can say. Okay, so these are the days mankind is scaring about viral diseases. Okay, viral diseases. So to give the solutions for viral diseases, so this is the important area, research area, which can provide RNA vaccines. Okay, what happens in RNA vaccines? Okay, so that means, in virus, messenger RNA, mRNA to produce, and which can be copied from the genetic material and synthesize such kind of RNA strands, so that the virus multiplies itself. The virus multiplies itself. Okay. So when it multiplies in the body, in the cells, then it attacks our immune system, and it can be gain strength, and it can destroy our immune system, and also ultimately humans will die. So therefore, what RNA vaccines can do? Okay, so that means if you understand the messenger RNA from that virus, you can synthesize that RNA in the laboratory, and you can give it as a vaccine to the man, to the human. So when it is given to the that human, that vaccine, RNA vaccine, so immediately that vaccine develops the immune system in our body, immune response. It produces antibodies in our body, which can fight the real virus when that person affected. So that's the logic behind these RNA vaccines. Okay, so future messenger RNA vaccine technology may allow for our one vaccine to provide protection for multiple diseases. So this is the greatness of this research work, right? Till now we have seen one vaccine for one disease, but with these RNA vaccines, one of the another advantage we have. So if you prepare one RNA vaccine, it can provide protection for multiple diseases. So that is the greatest important thing about this RNA vaccine. Okay, so therefore, what happens if one RNA vaccine works for multiple diseases? Then it decreases the number of shots needed for protection against. Okay, so therefore, a common vaccine preventable diseases. Okay, so it can reduce the number of shots a man can take. Okay, and also it is very useful and helpful to the research, to the future world. Okay, so those are the wonderful emerging trends which I explained. Then I want to explain you about targeting targets. This is one of the important area you need to understand in drug design and discovery. Okay, so macromolecular targets for drug design and discovery. What are the, suppose if you want to design a drug, or if you want to discover a drug, the key and important thing that man should know what is the target of the disease. Where is the location of the disease? What is the target? What is the chemical structure of the disease? Then only it would be very effective to design a drug for that, to discover a suitable drug for that. Okay. My dear students, you can remember this. And this is the important area in drug design and discovery. So what are the general targets for drug design and discovery? They may be proteins like enzymes and receptors, hormones, etc. There may be nucleic acids, DNA and RNA. There may be lipids. There may be carbohydrates. So these are the general major molecular targets, macromolecular targets for drug design and discovery. I explain one by one. So I suggest all the students, please listen carefully, and if you understand these things, it will become very easy for you to think about science and research. Okay, left side, whatever you are watching, left side, it is the structure of enzyme. Okay, if you see that structure, it may disappoint us. It may seems very complicated for us to understand. But if that is the target for a drug, for a particular disease, so to design a drug for that, you need to understand the drug target structure, chemical structure. That would be very effective. Okay, so you can see the tertiary and quaternary structure of proteins, secondary structure of proteins, and primary structure of proteins. Okay, initially, largely it looks like a three-dimensional structure. So if you clearly, and if you want to clearly understand about that part, that three-dimensional structure, if you go into deep, you know that enzymes and proteins, all those things are made up of with amino acids. Okay, amino acids. So there are about 25 number of amino acids only. Difference in the sequence, they can produce variety of proteins and enzymes, receptors. Okay, the only difference between them is the sequence of amino acids. If you are able to find out the sequence of the amino acids and the peptide bonds in between them, so that illuminates, that enlighten us in drug design very muchly. Okay, so therefore one must understand the chemical structure of a particular drug target. So this is also same for enzyme structure, three-dimensional structure and the parts of the enzyme, and analysis about the enzyme. And the left side, bottom of the left side, you can see the chemical molecules in that enzyme, which are made up of with these chemicals. Okay, so if you are able to understand the sequence and the kind of amino acids exist in that sequence, then it gives us great information to design but effective drug. And next, I want to show you about nucleic acids. This is also one of the major target for so many drugs. Okay, nucleic acids. You know, nucleic acids, three-dimensional structure. Okay. So the three-dimensional structure, and these helix, double helix DNA, single helix RNA, and those double helical DNA attached with and bind with each other through the hydrogen bonding between the pyrimidines and the purines, which are exist in their structure, and phosphates and sugars. Okay, amino acids are nothing but they are composed with the purines, pyrimidines. Okay, like cytosine, guanine, adenine, and thymine. Okay, and uracil, all those bases, and as well as deoxyribose carbohydrate and phosphate chains, okay, backbones. So these are the chemical structure of nucleic acid, DNA and RNA. If you are able to understand this chemical structure and this target, the drug design and discovery will become very meaningful and effective. Okay. In the left side, three-dimensional structure, you are able to see minor groove and major groove in between double helical DNA. Okay. So those are the grooves through which some minor groove binders drugs and major groove binder drugs will incorporate and insert into the DNA chain and incorporate in between them and bind with the bases and the chemical structures through hydrogen bonding interactions and ionic interactions and electronic interactions and van der Waals interactions, hydrophobic interactions. These kind of interactions takes place in between binding site and the drug. Okay, so these are the deep level one should understand to design a drug. So this is the clear chemistry picture I can give you. The two DNA chains in between, I wrote some name of the anti-cancer agents which can insert into the DNA through minor groove and major groove. So bottom of the red color anti-cancer agents will slip into the DNA through minor groove bind sites. Okay, so I did my research work in IICT after I qualified CSR exam. So I completed my MSc chemistry and MPhil chemistry from University of Hyderabad. And after I qualified CSR exam, I joined under the supervision of Dr. Ahmad Kamal, who was outstanding scientist in medicinal chemistry research. His main research area is anti-cancer agents. So I used to work in this area. I worked on pyrrolobenzodiazepines, novel pyrrolobenzodiazepines, new compounds I synthesized, and I studied my new compounds on anti-cancer cell lines, at least 60 cell lines from National Cancer Institute, USA. Okay, so we sent our prepared compounds or new compounds to the National Cancer Institute, USA, and they analyzed these cancer cell lines biological activities, cytotoxic activities, and they sent us the report and data of their analysis. And so when I saw them and I analyzed the results and discussion, and I found out few of them exhibiting promising anti-cancer activity. Therefore, so with the help of CSR funding, so we are able to patent 6 US patents from my research group, okay, from my research work. So one of them is PBD, spiralobenzodiazepines new molecule. So which has action of mechanism. Mechanism of action is they are minor groove binding agent. That means that compound slips into DNA through minor groove and incorporate in DNA and interact with the DNA bases and stop the DNA replication. That's how kill the cancerous cells. So, so that is about my research work. And the next, it is also one of the target for drug synthesis and design, lipids. Okay, so this is the lipid structure. So if you see the lipid, the head like hydrophilic head and hydrophobic tails. So why they behave as hydrophilic and hydrophobic? So you can see left side the chemical composition. So because of phosphates and polar groups in head, it acts as a hydrophilic head. Okay, so because of the alkyl chain and olefinic chain in the tail, they can act as hydrophobic tail. Okay, so if you it is important to understand the structure, drug targets, then in drug design and discovery, it gives us very effective information in designing a drug. So I want to give you one wonderful example how the drug mechanism of action in killing bacteria. Okay, so you know about antibiotics. Okay, one of the initial discovery of antibiotic is penicillin, right? So it kills the bacteria and it protected many millions of people from bacterial diseases in olden days. So I want to explain you the mechanism of action for that. So you can see peptidoglycan, the cell wall, so which is composed with the carbohydrates. Okay, in peptidoglycan, that layer composed with the carbohydrates. Okay, so I can show you what kind of chemical structure composed that peptidoglycan. So this is the chemical structure of that peptidoglycan. Okay, so in that peptidoglycan you have two sugars, different sugars, NAM and NAG, and in that NAM and NAG they link together, and they also have the chain of 5 amino acids: L-lysine, D-glutamic acid, and diamino alanophilic acid, and D-alanine. Okay, so these are the amino acid chains every sugar has, and in between these chains, transpeptidase, an enzyme which can connect a link in between those two, in between those amino acid chains. That's how, that is the last step by which the peptidoglycan layer will be synthesized in bacterial cell wall. Okay. So what penicillin will do to and act as an antibiotic? Okay, mechanism of action of penicillin you can understand here. So this one and this one, this is the transpeptidase enzyme which can make the linkage in between these two chains. Okay, in between these two chains. So this is the function of this transpeptidase enzyme. So what penicillin will do? Penicillin will come and occupy the active site of transpeptidase. Occupy the transpeptidase active site and it blocked the synthesis of that linkage. So that's how in the final step, the linkage between the amino acid chains will not be occurred. And therefore that bacterial cell wall will be destroyed or collapsed. So that's how penicillin kill the bacteria and protect as an antibiotic. Okay, all the antibiotics and similar to this penicillin will inhibit the function of transpeptidase. So therefore, the bacterial cell growth will destroyed and they can be cured from the disease. And I want to give you one more example about targeting HIV replication. Targeting HIV replication. If you know the process of targeting HIV replication and what kind of enzymes and important structures will contribute in this HIV replication, then in drug design and discovery, it helps a lot to design wonderful drugs for that. Okay, initially the HIV virus will come and incorporate into the host cell through CD4 and that GP41 proteins. Okay, the spikes, protein spikes, which are you can see in this picture. Okay, so here the virus can be bind to this protein and it can next step in the it can incorporate into the host cell, and after incorporating in the host cell it will open up its structures and all the structures and RNA, and this RNA in this RNA too it makes copy and synthesize the again another strand. For this reverse transcriptase, the enzyme will be useful, or that enzyme catalyze that biochemical reaction, and after that integrase will integrate that newly synthesized viral DNA into the host cell DNA, and the protease enzyme will help to synthesize the remaining parts of that RNA virus, and everything will come together, and they can go out as a new virus. Okay, so like this viral replication takes place in host cell. For this viral replication, it uses host cell. All these cycle happens in the host cell. Okay, so therefore from host cell itself the immune system will become weak, and all the viral genetical code and the genetic material will come out and synthesize the cell. All the immune system will be collapsed. That's how the patient will die with the HIV replication, HIV virus. Okay, so what is the solution for that? So there are if you want to design, so you can understand about reverse transcriptase inhibitors and their structure and their functions. You can also need to understand about integrase inhibitors and their structure and functions, and protease inhibitor, their structure and functions. And also you can block the G44 protein where the virus can enter into the host cell by designing a suitable drug. So these are the ways you can design a drug for anti-HIV agents. Okay, so I want to encourage you. I want to provoke you that, and I want to inspire you that. So once if you understand about the mechanism of action, and if you understand about the target of the drug structure, macromolecular target structure, and that gives to a researcher a lot of information to design an effective and suitable drug for particular diseases. So this is the main concept in drug design and discovery. Okay, so finally I want to show my experience with the top chemistry people in the world. Okay, so when I was in Tokyo in the international conference, so where I had a privilege to meet Ije Kore, who was the Nobel laureate, and still is doing wonderful research in chemical research, in scientific research. In the middle also is also the student of Ije Kore and topmost scientist in the world today in chemistry. So I had a privilege to meet them and got inspired from them, and I preserved this wonderful experience, this picture with me, and so that I am able to share with you this time. So thank you so much for your attentive listening of my lecture. I hope many of you have provoked and inspired by my lecture in the emerging trends, and as well as the targets for drug design and discovery. Thank you so much. Again, I want to thank all the organization people, especially principal. So actually, Dr. Prashanti contacted me about and invited me about this recently, and so I gladly took that invitation, and so I prepared myself to induce you with this lecture. Thank you so much, and if you have any questions, you can post to me.
Thank you, sir. We are privileged to have your session, sir, actually. And thank you for letting us know the recent advancements and emerging trends in science and technology, sir. Also letting us know the mechanism of drug discovery, target molecules and drug action, etc. I request all the participants, if you have any doubts, please, you can share your doubts. Sir, I have a question.
Yeah, please ask me.
Sir, is it high pressure inorganic chemistry synthesis, inorganic chemical synthesis, that can be considered as a green way of synthesis, green method of synthesis?
Yeah, absolutely. That can be considered as green, one of the methodologies for green chemistry, because hello.
Sir.
Am I audible?
Yes, sir, you are audible.
Yeah, I have just sound disturbance. Yeah, it can be considered as a green methodology, because with the high pressure and high temperatures and normal conditions that the reactions takes place. That's why it can be considered as green, one of the green method.
Okay.
Also, it reduces so much of cost of chemicals and reagents.
Thank you, sir.
Okay.
Sir, and can't we prepare biodegradable plastics? Because all these whatever biodegradable things, all those made up of carbon only, and this plastic, of course, is also a carbon material. Then why can't we prepare biodegradable plastics?
Yeah, that's a good idea and good question. Actually, the one of the emerging trend what I have explained in that research area, that is also one of the important concept that they shifted from polyvinyl chloride and polyethylene and all these harmful and dangerous chemicals. So they wanted to synthesize some biodegradable chemicals. So that is also one of the important concept in that research area. So we need to avoid these kind of chemicals, and still the research is going on that.
Thank you, sir.
Okay.
So actually, we are running out of time.
Yeah. Okay.
If everything goes well, we would like to have a offline session, sir, because you have provided very valuable information, which is very useful to our students. I thank Prashanti ma'am for introducing you to us for organizing this session. Now, I would like to invite Ms. Rubina Farhin Faruqi to propose oath of thanks to Dr. G. Balakishan, sir. Over to you, Rubina.
Good afternoon, everyone. I am Rubina Fareen Faruqi, lecturer in chemistry, TSW RDC Mahendra Hills. I am here to present the vote of thanks for today's webinar. I would like to thank our guest speaker, Dr. G. Balakishan, sir, for visiting and enlightening us with your knowledge. The point where Dr. G. Balakishan, sir, told us about the recent scientific innovations like emerging trends in scientific research like dual ion batteries, and gave the live examples was very innovative, and about the artificial intelligence of applied chemistry, where sir has encouraged about the chemical research and scientific research, and RNA vaccines was really informative. I am pretty sure the precious knowledge that sir gave us will definitely help us in our future. Once again, I would like to thank Dr. G. Balakishan, sir, for taking out time from your busy schedule and enlightening us with the knowledge and encouraging all the students and all the staff and all the participants who have participated in this webinar. Thank you so much, sir. Now I would like to invite Annapurna ma'am. Over to you, ma'am.
Thank you, Rubina. Thank you, sir.
Thank you.
Now I would like to invite Vinoda to propose overall oath of thanks.
Good afternoon to all. First of all, happy National Science Day to all. I am lecturer in chemistry at TSWRD. Takes this opportunity on behalf of Mahindra Hills Chemistry attending. Like to Dr. S. Praveen Kumar IPS, Additional DGP, Secretary of TSWREIS and TTWREIS for giving this great opportunity to strengthen our teaching community. Thank you, sir. I express equal gratitude to Dr. Praveen Mamidala, sir, Joint Secretary of TSWREIS and Head of Higher Education and DAR, for his constant support and motivational in all our endeavors. Thank you, sir. Thank you so much. And now I also thank to Dr. P. Bhanuprasad, sir, OSD, and Dr. Rajini Pasupuleti, ma'am, Judge of South Zone, for touching the code of all lecturers and encouraging them to do various activities. Thank you, sir, and thank you, madam. I express my sincere gratitude to Professor Dr. Ashok, sir, for his such a wonderful and valuable session on green chemistry, and sustainable chemistry. I'm sure, sir, all our students have got motivated to think and do all the things in green and sustainable manner. Thank you, sir. Thank you so much for your wonderful session. And I also express equal gratitude to Dr. G. Balakishan, sir, for his wonderful session on recent scientific innovations, young-minded science, drug discovery theory, letting us and our students to explore the scientific innovation in the field of chemistry. I hope they have joined. This is very clear-cut explanation, sir. Thank you so much. Thank you so much for your great-minded science. I sincerely thank to Dr. G. Nirupa, ma'am, Principal of TSWRDC Mahindra Hills, for her constant support and guidance in conducting in this program. Thank you, ma'am. Thank you so much. I thank to Dr. Prashanti, ma'am, lecturer in botany, and also Dr. Swaruparani, ma'am, lecturer in microbiology at TSWRDC Mahindra Hills, for their cooperation and support in organizing this webinar. Thank you, ma'am. Thank you for that. I thank to all my dear faculty members and students of TSWRDC family for participating in this webinar. I especially thank to Chemistry Department of TSWRDC Mahindra Hills for their selfless effort for organizing this webinar. Thank you, one and all. Thank you. Have a nice day.
Thank you, Vinoda. So I request all the participants to check for feedback form in the chat box to get e-certificate. And we have come to the end of this webinar. I request all the participants to stand for the national anthem.
हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगल दायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे.
Yeah, with this we have come to an end with of today's session. I thank all of you, especially the chemistry department. Wonderful job done by you. And Ashok sir and Balkishan sir, thank you so much for joining the session and making this seminar a wonderful session. And I hope we all know that before also we have conducted many international seminars and so on and so on. And because of his cooperation, we were able to do or conduct all these. And really thankful. Special thanks to Ashok sir for giving all this information to us. Aptly, the skills we have tried to increase our skills and all in the way of innovations and technology and science. So today's seminar is a great exemplary thing to follow of all these things, and hope so all the students have took a better opportunity of all this. Thank you, sir. Thank you once again. Thank you all of you once again.
Thank you, ma'am.
Shall we end the meeting?
Thank you, ma'am.
We can end.
Is Ashok sir there on the line? Just check whether Ashok sir is there on the line.
Not there.
Is not there?
Yes, he is there, madam.
Right. Anyway,
Ashok,
all of
he
you
is
well
there.
done.
Thank you,
Is
madam.
there? Okay, right, sir. Thank you. Thank you, ma. I think Vasanta was also there. She also had come.
She has joined initially, ma'am.
Okay. Right.
Joined, ma'am, actually.
Okay, right. Anyways, we'll have an end of this meeting. And well done, all the chemistry department.
Thank you, ma'am.
And also all the faculty who have helped out. Who all have helped out in this seminar. Okay.
Thank you.
Thank you, madam. All these
End the session. Annapurna, I think you have to tell them about the forms and all, no? The forms and all. Did you mention about the YouTube link and forms and everything?
Yes, madam.
We have shared
Okay, before
in the
closing the
Zoom.
session. Yeah. So I told
We have
about the
already
credentials that
shared
you
in
have to
the
follow.
Hearty congratulations, Dr. Nirupa.
Thank you, sir. Thank you so much. It's just because of you.
And
You have made this.
hearty congratulations to you and your team. You have
Yes.
nicely arranged. Thank
Thank
you
you
very
so
much.
much, sir.
All the very best.
so much, sir. Thank you.
Thank you.
Yes.
Thank you.
Thank you so much.
Yes,
We
yes.
expect the same type of cooperation from you all the time, sir, to our
Yes, sir,
college
definitely,
and maybe
definitely.
our students.
It is an opportunity for me.
Yes, sir. Yes. Right. Thank you to have you here, sir. Right.
Thank you. Thank you very much.
Annapurna, you'll end the meeting or me? Who will end it? I mean, how to, you know how to end it?
Yes, madam, I will end it.
Hello, ma'am. Hello.
Madam,
Stop live streaming.
Yes, ma'am. Evening.
Stop live streaming and then end it. Sandhya, you are doing the meeting on a laptop or a mobile?